Spotify, man. Got free range. Got free range to say whatever the fuck you want. Like, free range chicken in this bitch. Word up. You are मेरे पास एक कोई कॉम्बिनेशन है अब इसका वो सर्टेन वेट होगा फिर इस तरीके से मेरे पास मल्टीपल स्पेलिंग था उन सब स्पेलिंग से जिनका भी मिनिमम वेट होगा दैट इज कॉल्ड योर क्लियर इतना सीक्वेंस बेसिस के बाद हम स्टार्ट करते हैं इस चीज को डेवलप करने
हेलो एवरीवन, वेलकम टू माय चैनल कोर्स और मैं कल मैथ्स के इंग्लिश का वीडियो नंबर 29 करने जा Now, the saving will be required is not minimum requirement is minimum weight जो पहले सबसे पहले
algorithm similar kind of game. Calculators के लिए क्या यूज कर रहे हैं? हमने सोचा ये तो सोचा हो क्या करेंगे पास करेंगे ऐसा हम पास करेंगे जब हम कोई भी चीज राइटिंग उसे बाहर निकालेंगे ठीक है एक सिंगल चीज है मेरे पास मेरे पास मैं बाहर निकाला मेरे पास हुआ सब रेडी हुआ सारे बात ये तो मेरे पास था वही जैसे मैंने विजिट को चेक किया अब मेरे पास विजिटिंग खत्म हो चुकी है तो मेरे को क्या करना है इसे यूनिवर्स में स्टोर करना है और ऑब्वियसली अगर मैं जैसे बनाया नहीं उसके लिए स्टोर करना है टाइम मेरे पास क्या है टू लेकिन क्या है ये बता दिया होगा प्राइवेट मैंने पहले ही तय करा होगा ये टू मेरे पास है अभी तक दो बार मैंने चेक किया पहला कब जब हम जब हम देखे दूसरा कब दो बार इनमें से कौन सी मेरे पास बाहर रहने वाले हैं अगर आपको आपको प्रिंट करना है थोड़ा एजेस कौन सी एजेस है उसमें पार्टिसिपेट करना है तो आप एक मैंने ऐसे है कि मैं पार्टिसिपेट जैसे आप लोगों को जैसे यूनिवर्स में पास है मतलब जितनी नोट्स है मेरे पास सभी इसके यूनिवर्स है क्या मैं और फिर हमारे पास सिंप्लीफाई करने के लिए रिक्वायर्ड है 2 फीट और 3 से 4 करने के लिए रिक्वायर्ड है क्लियर है कोई डाउट यहाँ पे पूछ रहे हैं चलो अब ये बताओ ये अवेलेबल है ये इनमें से कौन सी ऐसी नोड होगी जो बाहर आने वाली है आई गेस मेरे हिसाब से ये वाला प्रोडक्ट के बाद जो है क्योंकि सबसे पहले हम देखेंगे पहले इंडेक्स पे मिनिमम क्या है पहले इंडेक्स पे मिनिमम मेरे पास क्या है 1 फिर हम देखने वाले अगर दो सेम है तो फिर सेकंड इंडेक्स पे मिनिमम क्या है इट मींस द नोड इज गोइंग टू बी 2 and the weight is going to be 1 the parent is समझ में आया क्या नोड 2 मेरे पास अभी विजिट है and that means to market is a weight कितना है सर डायरेक्ट मेरे पास ये है मैंने जैसे इसको लिया मतलब टू मार्किंग टू इंक्लूड द पार्ट ऑफ क्लियर हो अब मेरे पास तो ये लेवल्स क्या क्या है 1 एंड 3 एंड 4 एंड 5 1 और 3 मेरे पास पहले से विजिबल है 1 और 3 मेरे पास पहले से विजिबल मतलब ये राइटिंग में नहीं जाएगा राइटिंग टू क्या इक्वल होने वाली है 4 5 इसकी हेल्प से ठीक है अगर मैं 2 से 4 जा रहा हूं 2 से 4 पॉसिबल है समझ में आ रहा है? अब मेरे पास नोड 4 क्या विजिट है? Next you need to mark it listed. Weight कितना है? Plus 5. Weight हो गया. And the node is 4, मेरे पास क्या हुआ है? इसका अब मेरे पास ये नोड 4 चल रहा था, इसके नेबर्स क्या है मेरे पास? 3 और बोलो 5. क्या 3 को वैल्यू वैल्यू दूंगा? क्यों नहीं दूंगा? अब एक्सपेक्ट करने वाला 5 को किससे वेट कितना होगा? समझना? अगला मेरे पास नोड कौन सी बाहर आने वाला है? 2 कॉमा ये वाला बाहर आएगा। नोड मतलब मेरे पास आया 2 वेट कितना था? 2 और वेट क्या था? क्या मेरे पास नोड को पहले से दिया है? जो चीज पहले से दिया है अब मैं उसको सिंपलीफाई एक्सपेक्ट करूंगा और ना ही टेबल ना ही सब ना ही सब
teacher denoting the count
मतलब
of
यहाँ से मैं
resistance
इसको
that is
इग्नोर कर दिया अगला मेरे पास कौन सी बात है?
so there is a continuous non-regressive sequences of element with 18 4 in this example the distance of the is a very huge
अब अगर आप देख रहे हो तो हमारी सारी नोट्स में जो छुट्टियां राइटिंग में कुछ एंट्री
there
नहीं
is
होगी
an
और
index
इसके बाद मेरे पास ऐसे में इसको निकाला इसका मतलब हुआ अब ये वाली एंट्री बाहर आएगी है ना लेकिन हम चेक किसके करेंगे अब फाइल के लिए फाइल क्या होगा पहले से प्रेसिडेंट क्या उसको कोई टास्क परफॉर्म करेंगे when we are next को बाहर निकाला फाइल के लिए फिर से चेक करेंगे क्या ये हम इसमें कोई टास्क परफॉर्म करेंगे ये कब तक हुआ जब तक राइटिंग क्यू एमपी क्लियर हो अब मेरे पास टोटल एडमिशन का वेट कितना है 5 ठीक है पूरा एलएस 1 2 4 क्या एग्जैक्टली 4 एलएस है मेरे पास अगर मैं बोलूं तो ये कौन सा है 1 से 3 और 3 से 2 3 से 4 और 2 से 5 ये मेरे पास केमिस्ट्री बन गया क्या ये पॉसिबल मिनिमम वेट वाला नहीं था मेरे पास ग्राफ था वही है समझ में आया एल्गोरिथम
0 to 2 which is
कुछ पूछना है यहाँ पे
3 to 4
बस ध्यान क्या रखना है कि हम लोग दो बार प्रेजेंट चेक कर रहे हैं जब एंट्री कर रहे हैं और जब बाहर निकाल रहे हैं और वेट हम तब कंसीडर करेंगे डिजिट मार्क तब बैठेंगे जब हम 0 to 5 से बाहर निकालेंगे ठीक है क्लियर है और डिस्कस करें इसको What are the requirements? Perform memory can be within or visited array. The first thing is visited array. कितने साइज का? If it is a 0 base, then it size. If it is a 1 base, then n plus 1 size. Initially filled with the then we require a priority. ठीक है किस तरीके का होना चाहिए रियल ट्रांजिशन अब हमारे पास दो टास्क है या तो मैं चाहूं तो एमएसटी को भी प्रिंट करा सकता हूं ठीक है कि कौन कौन सी एजेस आने वाली है लेकिन हम लोग उसको नहीं बोल रहे हैं हम लोग क्या प्रिंट कराएंगे कि सिर्फ मिनिमम वेट क्या होगा और उसको कैसे प्रिंट कराना है एमएसटी का पहले इसको इंप्लीमेंट करो फिर वो बताना
हमने बोला पेयर, then the second thing
से
we
पहले
require
दो
वेक्टर
सॉल्यूशन
वेक्टर
की क्वेश्चन
कोई भी सही देगा,
0 to 1 में
पेयर करेगा, then एक वेक्टर फंक्शन
so that is
जो
0
क्या
to
रहता
1
है,
to 1 में there is no index of I in relation to one satisfying
दोनों चीज हमारे पास
0 is what can be
जो भी
shown
मेरे पास सोर्स है या फिर जो आपकी पहली नोट
other
है
instances are arranged such that the answer is true.
पहले स्टेप पे मेरे पास क्या आता है, पहले इंडेक्स पे क्या आता है, वेट, दूसरे इंडेक्स पे अब हम जब हम चाह रहे हैं कि एमएसटी का मिनिमम वेट प्रिंट हो तो मैं नहीं चाहता कि मैं बस डायरेक्ट का भी डायरेक्ट में कब चाहिए था जब मैं एजेस को स्टोर कर रहा था तो मैं सिर्फ इन दो का पेयर यहाँ पे इसके डायरेक्ट लेके चल रहा था तो कोई एग्जांपल मेरे को किसी भी नोड पे जाना है जो भी सोर्स होगा इनिशियली तो वेट उसका 0 ही रहता है दिस इज एक्स ओके समझ में आया ऊपर एस हमने सोर्स नोड दिया क्या मैं यहीं पे इस नोड को विजिट मत करने वाला हूं जैसे मैंने पहले एक्सपेरिमेंट किया
जो चॉइस की
आए ना जैसे
चॉइस को इग्नोर करना
नहीं करने वाला हूं क्योंकि हमने क्या बोला कि हम विजिट मत तब करेंगे जब प्राइवेट सिस्टम को
दोनों चॉइस जितनी चॉइस है पूरे बैकग्राउंड
अब मेरे पास मेरे को इस नोड पे टास्क परफॉर्म करना है मेरे को ये नोड चाहिए होगा
वो बेसिस के टेलीफोन से
वहां पे मिलेगा नोड राइट
बोल
अब मेरे पास कुछ कंडीशंस यहाँ पे आ रही हैं क्या कंडीशंस आ रही हैं क्या कंडीशंस है कि सबसे पहले तो हमें यही चेक करना है कि the vicinity of a particular node जो यहाँ नोड अभी कंसीडर किया कोई तो सिंपल है पहले की जो नोड हमने निकाली वो विजिट है तो उसमें हम क्या कोई टास्क परफॉर्म करते थे नहीं करते थे नाइस ये वाला नाइस का वेट मैंने बोला सीधा क्लियर है अब अगर मेरे पास ऐसा नहीं है तो मेरे को क्या करना पड़ेगा एक सब वेरिएबल होगा उसमें मैं इक्वल करूंगा ओके दूसरा टास्क क्या करूंगा विजिट करूंगा नोड को समझ में आया ये टास्क कंप्लीट हो गया अब मेरा बचा क्या टास्क सिर्फ नेबर्स को एक्सप्लोर करना वो कैसे होगा फॉर लूप करना तो आइटरेशन इसमें रेजिस्टेंस को नोड नंबर अब मेरे को एक बात बताइए मेरे को नई नोड चाहिए नोड एंड अब यू वेक्टर इंक्लूडिंग क्या है मैं एक जगह खड़ा हूं दूसरे नेबर्स को मैंने देखा उसका वो नई नोड क्या होगी और उस तक जाने का नया वेट क्या होगा यही है मेरे पास ये कैसे पता चलेगा मेरे को अच्छा लिस्ट से पता चलेगा आया ना चलेगा अब मेरे को कौन से इंडेक्स पे मेरे को वेट मिलेगा कौन से इंडेक्स पे मेरे को नोड मिलेगी बताइए अगर मेरे को टू जाना है तो ये निकालना है मेरे को इधर जाना है मुझे भी वो भी ऐसा ही करना डायरेक्ट लिंक से क्या होती है नोट दूसरे लिंक से that means इस आइटरेटर का जो भी पहला इंडेक्स होगा उसको मेरे को नोड मिल जाएगा इस आइटरेटर का जो भी पहला इंडेक्स होगा उसको मेरे को वेट मिल जाएगा अब अगर if the visited array not visited a particular new node जो निकाल रहा है
दूसरे में से इस तरीके से हमारे पास एक पूरा फंक्शन डिजाइन हुआ एंड द एंड आप क्या करोगे रिटर्न करोगे ये क्या ये अगर मैं आपसे कहूं इसकी जगह है राइट
सरहद
अब
पार
प्रश्न ये
से
है
मुझको भेजा है ये पैगाम
अगर
उसको
वो
नफरत सी
हमारे
हो
पास
गई है मेरे नाम सरहद पार से मुझको भेजा है ये पैगाम उसको नफरत सी हो गई है मेरे नाम से मेरी तो दुआ है सारे एक हंसी हंसे रब्बा मेरी तो दुआ है सारे एक साथ बसे सभी एक थाली बांटे ना के खून के हो प्यासे रब्बा किस्मत से एक भी कम न लिखो सांसे मेरे भाई लो फिर लिखा ये खत तुम्हारे नाम में तो खुद परेशान कि ये लोग या हैवान ये इंसान की जान के प्यासे ऐसे ये गवार खून सर पे सवार इन्हें भुला हुआ होता है ये तो मर्द है कमजोर जिनके हाथ में हथियार है नफरतों से प्यार बैठे जंग को तैयार है मैं सोचता हूँ अक्सर इनकी कैसे ही जमीर है जो जान लेगी किसी की सुकून से फिर जीते बरदोस ये जो मजहब के बनते रखवाले सब ढोंग है बस अंदर से खून के ये प्यासे सब मकसदों को लाते हैं ये मजहबों में ढांक के मुल्क और मजहबी इन कमसरफों की ढाल है लिखाई को ये मेरी सूते खौर से जो तुम भी ये मुल्क और मजहब में मिला किसी को न कुछ भी अमीरों ने बेचे गरीब को ये मसले के बच्चा गरीब का इस सब से न निकले ये फौजी हमारे खरीदते रहे असले ये लीडर भी मांगेंगे वोट इसी हक पे पर मैं तुम अक्लमंद है तो लाजिम है हम पे कि नफरत और वहशत की चालों से निकले मैं जानता तू दुख में कि छोटी न बात ये पर नफरत का नफरत से होता नहीं इलाज के ये चाहते हैं रखे सदा मुझे तुझे बांट के धर्म कोई बड़ा ना इंसान की जान से हम मेरी तो दुआ है सारे एक हंसी हंसे रब्बा मेरी तो दुआ है सारे एक साथ बसे सभी एक थाली बांटे ना के खून के हो प्यासे रब्बा किस्मत से एक भी कम न ले कोई सरहद पार से मुझको भेजा है ये पैगाम उसको नफरत सी हो गई है मेरे नाम सरहद पार से मुझको भेजा है ये पैगाम उसको नफरत सी हो गई है मेरे नाम से
Hello everyone, welcome to my channel Code Story with Mike. तो आज
जो हमारा कॉलेज सेशन का सेट नंबर 2 था वो था या तो इसके बाद सेट नहीं था उसमें हाईएस्ट 3 नंबर ठीक है आई अब बल्कि सेट ए के पास था उसमें से तो उसमें करीब तो 10 15 के पास This implementation has spread out in my so you are in the things. Right? Because they are so from the next week, आप सभी लोग अपनी फाइलें लाना शुरू कर दो। नेक्स्ट वीक से जो भी क्लासेस में बाहर कल शुरू फाइलें थे।
Hi there. This is a test message with air conditioning in the background. Normally, it'd be difficult to carry a conversation with someone as a result of this background noise, but with NVIDIA's AI-powered noise removal, distracting sounds can
Five, six, seven, eight, nine, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22,
कर देंगे। ये जो सदर है ऐसे जो भी मॉडल्स है इसका क्या वो 0 तीन चार 13 और 19। ठीक है। Some make it a problem that can be solved into let count be the number of indices where nums of I modulo mod is equals to k among the first I index. Count of
Accommodation हो गया तो लिटरली पूरा समझे करने का आता नहीं क्या
let count of number count count be the number of indices where numbers of I is equal to modulus of I. ठीक है प्रोफेसर निकाल कर इतने तक तो फिर क्या count of 0 is equal to 0 I is equal to I minus 1 plus numbers of तो 0 indices
काम करो मुझे पता है पहले क्या समझते बैक का किसी फंक्शन को दोबारा कॉल करके सकते हैं मुझे ये नहीं पता था कि बैक करके इन लोग कमांड होता है पहले काम कर चुके हैं इन लोगों को
n is equals to 0 count of I is equals to count of I minus 1 some kind of this is prefix indices. J greater, J is smaller than I such that count of multipliers equals to in count of I minus becomes count of J is equal to 1 I plus you are taking just much of each. We just sum up all count before increasing map count on the total session. Same.
उसमें मैथ्स के प्लेलिस्ट का वीडियो नंबर 29 करने जा रहे हैं। मैं आपको हर चीज़ का रीज़न बताना चाहता था, इसीलिए मैंने पूरा बैकग्राउंड दिया आपको। यहाँ पर मिन वैल और मैक्स वैल क्यों पिक्चर में आया, ताकि हम अपर और लोअर बाउंड एक्सीड ना करें जब भी हम एक कांस्टेंट वैल्यू।
Now everybody, who are done with this code, open the let's enter and look at the question number third of week 7. Look at the question number third of week 7. Well,
modulo and k. Okay, your task is to find the count of more integers modulo and k. Okay, your task is to find the count of subarrays that are interesting. Now what is an interesting subarray? So a subarray L2R is interesting if the following condition holds true. What is that condition? Let count be the number of indices I in the range L2R such that nums of I mod, when you take mod with this modulo, it comes out to be k. So whatever is the count of element, again take mod with modulo and that should come out to be k. So if this is true for a subarray, that subarray is interesting. Return an integer denoting the count of interesting subarrays. Okay, what does it mean, right? So 3 2 4 is my example, right? Now Let me generate all these subarrays. So 3, 3, 3, 2, 3, 2, 4. Then 2, 2, 4, and then at last you'll have 4. So if I take I have to take mod with 2. Remainder should be 1. So if I take mod with 2, remainder is 1. So that means this I have one element like this. Here I have only one element because only 3 is valid. If you take 2 mod 2, the remainder is 0, but you want 1, right? Similarly here, this is valid, this is not valid, this is not valid. So count of element is 1, which is valid, right? For this one, again, you get remainder as 0, so 0 elements are valid. For this one, again, 0 elements are valid. And for 4, again, 0 elements are valid, right? So now, for each subarray, we have counted how many elements are valid. The validity condition is this, right? How many elements are valid in each subarray, and an element is valid if you take modulo with if you take mod with modulo and you get a value k. Okay. Now you have this count. Now again take mod with modulo. What do you get? You get 1. That means this subarray is valid. Similarly, count is 1. Take mod with 2. Again you get 1, and that is what you want. Again, this is valid, this is also valid, this is not valid, not valid, not valid. So there are 3 subarrays which are valid: 3, 3, 2, and 3, 2, 4. So 3, 3, 2, and 3, 2, 4. Two-step process. That means in every subarray, first find out the valid elements, and once you get the count of elements in a subarray, again take mod with the given value. That means take the mod with modulo, and if the remainder comes out to be k, then that subarray is interesting, right? Similarly, let's take this one, 3196. Let's generate all the subarrays. So 3, 3, 1, 319, 3196. Then you have 1, you have 1, you have 196, you have 9, you have 96, and then you have 6. Now I have to take mod with 3 of every element, remainder should be 0. So is this valid? Yes. One element valid, one element valid, two elements valid, right? 3 and 9 are valid here. Because even for 9, if you take mod with 3, remainder is 0. Here 3 elements are valid, 0 valid, 1 valid, 2 valid, 1 valid, 2 valid, 1 valid. Great. So I have the count of valid elements in every subarray. Now again I'll take mod with 3 of those counts, and the remainder should be 0. So for this one, is the remainder 0? No. 1 mod 3 valid. 3196. Let's generate all the subarrays. So 3, 3, 1.
ध्यान से देखना, इसका मैट्रिक्स मेरे को बनाना है तो कैसा बनेगा? 1 2 3 1 2 आ जाना है 0 2 0 3 0 4 4 0 1 2 2 यानी कि डिस्टेंस ये है डिस्टेंसेस। ध्यान से देखो, सेम तरीका हम कैपिटल मैट्रिक्स बनाते हैं, उसी तरीके से हम लोग यहाँ पे बात करने वाले हैं। लेकिन जो रिड्यूशन होगा जो आप आगे वो डिपेंड करेगा इस मैट्रिक्स पे, इस तरीके का रिड्यूशन होगा, वो आपको थोड़ा सा सोचना पड़ेगा चीजों के बारे में आपको सोचना पड़ेगा। फिर हमारे पास वे हैं 2 से 3 2 2 3 2 2 4 3 2 1 3 2 2 3 2 4 4 4 2 4 2 3 इस तरीके से मेरे पास एड्रेस दिख रहा है और कुछ इसको बोला जाए कि आपका ईगो डिस्टेंस है बी डिस्टेंस है बी के डिस्टेंस है ये मेरे को क्या बता रहा है कि आपको इस नंबर पे एड्रेस का हो जाना है अब दूसरे बड़े दी जाने के लिए हमारे पास ऐसे कौन सा हमारे पास क्वेश्चन है बस से आप 2 से से फोर से ठीक है, देन वन से टू से वन से फोर, फोर से इसके जाने का मेरे पास कितने नंबर है जरा, इसके जाने के लिए, इसके जाने के लिए दैट मींस हमें इसको इन्वॉल्व नहीं करना है, चाहे वो कितना भी मिनिमम कॉस्ट। अब हमें पार्टिसिपेशन में मेरे पास ये है, तो एक हमारे पास एज आपने कंसीडर किया हो 1 2 3, there is a edge from 1 to 3, इसको मतलब मैं इसको भी बोल करूंगा, इसको पार्टिसिपेट कराऊंगा सिर्फ इन दो को पार्टिसिपेट कराने के लिए अब मेरे को बताइए क्वेश्चन पढ़ रहा है तो बता दो कोर्सेस 1 2 3 5 7 1 4 दोनों का हमारे पास इसमें से कौन सा पिक करने वाला, the which one I am going to pick minimum, ठीक है। अब इस क्वेश्चन को कैसे चेंज करना है,
3196, then you have 1, you have 1, you have 196, you have 9, you have 96, then you have 6. Now I have to take mod with 3 of every element, remainder should be 0. So is this valid? Yes. One element valid, one element valid, two elements valid, right? 3 and 9 are valid here, because even for 9 if you take mod with 3, remainder is 0. Here 3 elements are valid, 0 valid, 1 valid, 2 valid, 1 valid, 2 valid, 1 valid. Great. So I have the count of valid elements in every subarray. Now again I'll take mod with 3 of those counts and the remainder should be 0. So for this one, is the remainder 0? No. 1 mod 3 is 1, not 0. What about this one? Is this 0? No. 1 mod 3 is not 0. 2 mod 3, not 0. 3 mod 3, yes, it is 0. Okay. This is 0. So 0 mod 3 again. This is also valid, not valid, not valid, not valid, not valid. So there are two subarrays which are valid. Which are the subarrays? 3196 and 1. 3196 and 1. Okay. I hope the problem statement is clear, right? What it is asking us to do. Two-step process. First, find the valid elements in every subarray. Now, for each subarray, find the count of elements which were valid, and again take mod with that value and see whether you get the required remainder or not. Right? This is what the problem statement is, right? Now, let's move step by step, right? The first thing is you find the valid elements, right? So for a given array, find the valid elements. This is valid, not valid, valid, valid. Okay. Now, obviously I cannot generate all these subarrays because the range is large, right? I cannot generate all these subarrays. Rather, what I can do is, if I can somehow convert it into sort of a prefix array or something like that. So why I'm converting it, I'll show you that as well. So number of elements from 0 to I. So till here I have one valid element, till here I have 1, 2 and 3. What is this saying? This says that a of I gives you the count of elements which are valid from 0 to I. Right? This is what this particular prefix array means, right? Prefix array means. Okay. Now, once you do it, just see what we need to do, right? Also, obviously, we need to take mod, right? We need to take mod of this count. So we can take mod there itself. Like for example, these are the count of elements in each prefix array. So what I can do, I can take mod with 3. So taking 1 mod 3, 1, 1, 2, and 0. So this is the final prefix array that you get. I've just taken mod. Why I've taken mod? Because ultimately I have to deal with mod, right? That I the count of valid elements in a sub array, I have to take its mod. So why not take mod here itself? So now you just have to do the subtraction part, right? Now what happens? This problem reduces to a very standard problem. What is that problem? That given a prefix array now, okay, you have to find the number of subarrays satisfying a condition, satisfying a particular condition, right? Now let's see some of the more things, right? I'm standing here, right? I'm standing here. This information says that if I take mod of count of elements from 0 to I, right? Count of, if I take mod of count of valid elements from 0 to I get 2, right? Now, the required remainder is k, but from 0 to I, I'm getting a remainder as 2. So ideally, if I can get 2 minus k mod m as the remainder, if I know how many prefix arrays are ending with this remainder, then that will give me the count. Why that will give me the count? Just taking an example, this is your prefix array. You want to find how many sub arrays are valid, right? Elements from 0 to I. Find the valid elements. This is valid, not valid, valid, valid. Okay. Now, obviously, I cannot generate all these subarrays because the range is large, right? I cannot generate all these subarrays. So rather, what I can do is, if I if I can somehow convert it into sort of a prefix array or something like that. So why I'm converting it, I'll show you that as well. So number of elements from 0 to I. So till here I have one valid element. Till here I have one, 2, and 3. What is this saying? This says that a of I gives you the count of elements which are valid from 0 to I. Okay? This is what this particular prefix array means, right? Prefix array means. Okay. Now, once you do it, just see what we need to do, right? Also, obviously, we need to take mod, right? We need to take mod of this count. So we can take mod there itself. Like, for example, these are the count of elements in each prefix array. So what I can do, I can take mod with 3. So taking 1 mod 3, 1, 1, 2, and 0. So this is the final prefix array that you get. I've just taken mod. Why I've taken mod? Because ultimately I have to deal with mod, right? The count of valid elements in a subarray, I have to take its mod. So why not take mod here itself? So now you just have to do the subtraction part, right? Now what happens? This problem reduces to a very standard problem. What is that problem? That given a prefix array now, okay, you have to find the number of subarrays satisfying a condition, satisfying a particular condition, right? So that, for example, these are the count of elements in each prefix array. So what I can do, I can take mod with 3. So taking 1 mod 3, 1, 1, 2, and 0. So this is the final prefix array that you get. I've just taken mod. Why I've taken mod? Because ultimately I have to deal with mod, right? The count of valid elements in a subarray, I have to take its mod. So why not take mod here itself? So now you just have to do the subtraction part, right? Now what happens? This problem reduces to a very standard problem. What is that problem? That given a prefix array now, okay, you have to find the number of subarrays satisfying a condition, satisfying a particular condition, right? Now let's see some of the more things, right? I'm standing here, right? I'm standing here. This information says that if I take mod of count of elements from 0 to I, right? Count of, if I take mod of, count of valid elements from 0 to I, I get 2, right? Now the required remainder is k, but from 0 to I, I'm getting a remainder as 2. So ideally, if I can get 2 minus k mod m as the remainder, if I know how many prefix arrays are ending with this remainder, then that will give me the count. Why that will give me the count? Just taking an example, this is a prefix array. You want to find how many sub arrays are valid which are ending here. And suppose the remainder that you get here is x. But what is the remainder that you want for valid sub arrays? That is k. So x minus k mod, this is the required remainder. That means whatever are the sub arrays which have this remainder, whatever the prefix arrays. Suppose there are some sub arrays which are ending here, okay, which have this as the remainder. So that means from here to here, this forms a valid sub array. This forms a valid sub array. So to understand it better, just consider it like this: that if you know the sum of elements from this to, from here to here, right? Required sum is k, and you have got a sum of x. So you just subtract these two to get the number of sub arrays, right? So you say that, okay, how many arrays are there with x minus k as the sum? How many prefix arrays are there which end here, right? You just add those, because after these sub arrays, whatever the starting index, after those, and this is the ending index, this is the count of sub arrays, right? So this is how we solve this problem. This is how we solve this problem. The two-step process. Ultimately, this reduces to a very standard problem, right? Let me show you the code to get a better feel of this. Also, in these cases, you also take an edge case. Otherwise, your solution will fail. What is that edge case? Okay, this is the array. Okay, first thing first. Let me again draw a diagram to show you one extra thing. Because maybe if you're seeing it for the first time, you don't know it. Look, this is my array. Suppose this is my prefix array. Suppose the sum of elements still here is capital X. Okay? And the total sum I want is S. Okay? So I do S minus X. Now that is, let's assume y. And there is a subarray whose prefix sum is y. Okay. So what does this mean? This means that if this is the index j, this is the index I, then a valid subarray in this case will be from j plus 1 to I. Getting from j plus 1, because still j the element is included. After this one, it becomes a valid array, right? Now, to tackle this, suppose a valid subarray is a prefix array. I mean, elements from 0 to index I is also a valid array, right? So to include that count, what you do, you say that the number of subarrays whose sum is equals to 0 is 1. Which is that subarray? When you do not take any element. This is the edge case that you had, right? So let me show you. This is the map that I've taken. Keep a track of that. For this particular model, how many subarrays are there? How many prefix subarrays are there, right? The number of elements I have, this is the answer. This is the edge case answer. That for 0, you have one subarray when you do not take any element, right? Now this is the prefix remainder. I goes from 1 to 1. What is the prefix remainder? Whatever is the prefix remainder plus, if the current number is also valid, add 1, else add 0. Okay? No need to create a prefix array. Even a single value will be sufficient here, right? So this is the remainder that I have for the current prefix array from 0 to I. Okay? What is my target remainder? Look, I want it to be k. I have got prefix remainder, so I subtract it. Now this value can also be negative, so I just add m because I'm taking mod with him, right? I'm taking mod with him. So again, standard mathematics, right? This
एक को एक्सेप्ट कर चुके हैं, एक एज को एक्सेप्ट कर चुके हैं।
हाई लेक्सोग्राफिकल ऑर्डर क्या होता है?
ये सबसे टफ चीज था अभी तक जो कर रहे हैं, ये सबसे टफ चीज थी। अगर अब आपने बोला इसलिए मेरे पास ग्लूकोज मेरे को कैलकुलेट करके दिया, समझ में आया क्या? ठीक है। अब मेरी I2B मैं जा रहा हूँ सिर्फ 1L बची है और दिस L हमें की की वैल्यू 2 रखना था, तो इसमें मेरे पास 1 वैल्यू बचा होगा। अगर वो एग्जिस्ट ही नहीं करता, वो एग्जिस्ट ही नहीं करता, क्या रिटर्न आएगा? वो रिटर्न करेगा is if not या हमारे पास ये ग्लूकोज जो कैलकुलेट कर रहे हैं नॉट इक्वल टू इनका भी हमें सॉल्व करना है। अब मैं काम क्या करना है, इस कोस्ट वेरिएबल को अपडेट करना है, क्योंकि एक कोस्ट वेरिएबल ये है ना हमारे पास कैसे ये कोस्ट वैसे क्या कोस्ट का। अब जो ग्राफ में मैंने कैलकुलेट करके कोस्ट आया ग्राफ को I and this plus this अभी क्या है ये तो वो चीज है जहां से हम जाने के लिए ये न्यू कोर्स क्या कर रहा था आई नो बी है समझ आया न्यू कोर्स आई इन दोनों में से जो भी मिनिमम होगा वो क्या हो जाएगा। ठीक है, बस दो चीजें आपको ध्यान रखनी है, फंक्शन कैसे कॉल करना है यूनिवर्सिटी, फिर हमारे पास कोर्स को कैसे अपडेट करना है। क्लियर है? अब हमारे पास ये सब चीजें तो हो मेन काम तो बताओ बचा क्या है, फंक्शंस तो कॉल कर दिया, काम कंप्लीट कर दिया, कैलकुलेशंस कैलकुलेट कर ली, रोकेंगे कहां इसको, ये कैसे है ना, जिसको केस केसेस हमें उसको टाइप करना पड़ेगा। कैसे केसेस, सबसे पहला कंडीशन क्या हो सकता है कि आपसे बोला जाए कि वर्क से बन जाना है, सेम डेस्टिनेशन सेम सोर्स, तो इसमें कितना होना चाहिए, मतलब ये इक्वल टू 0 एंड ये कंडीशन हमारे लिए सही है, इसमें बता सकते हैं ऐसा कौन सा, इसमें क्या वैल्यू हम बता दें जब आपसे पूछे सोर्स
This is target number. Now answer plus equals to see how many prefix arrays are there which have this as the property. This is the prefix sum, prefix mod sum, target sum. If they, whatever is wrong, just add it. So get by default, if there is something, add it, else add 0. And then after you do this, add the increment the count for prefix remainder. So map dot put prefix remainder, just increment the count. Finally, you return the answer, right? So it's a two-step process to reduce it to a very standard problem, right? To a very standard problem. And I think most of the people where they failed was because of these two, this condition, this line. That if they did not know how to calculate the target number, right? Once you know it, you can do it easily. So just whenever you're not able to understand it, just try to map it with a very standard problem. That okay, I want the number of subarrays with a particular sum. Then what would I do, right? The same solution will work here. Obviously, you need to tweak it a little bit, but 99% of the things will be same, right? That is how you map the problems. So a given problem can be mapped to a standard problem, right? This is how you come up with the observations, right? So yeah, that's it for the solution. I hope you answered from this video. Do support it by giving it a thumbs up, do subscribe to the channel as well. In case you have any issues related to the solution, please mention that in the
बचा हुआ सिग्नल वाला ऐसे प्लीज यहाँ पे सिग्नल नहीं है, इसलिए वाला कैसे इतना सा मेरे पास कोड है, लेकिन ये कोड
बेसिकली मतलब आई जो है ना, तो आई प्लस वन से छोटा होना चाहिए और लेक्सोग्राफिकल ही समझ में नहीं आ रहा और अच्छा all limits should be
उसका नेबर्स नहीं है, उसका नेबर ही हो सकता है, कोई चीज में डायरेक्ट ग्राफ नेबर होगा तो ग्राफ में इसको देखो उसका आप याद रखो, आप कहीं पर भी ग्राफ में वैल्यू को अपडेट नहीं कर रहे हो, मतलब ग्राफ में डायरेक्ट बस यूज कर रहे हो, आप लोगों ने चलो थोड़ा सा इजी कर देता हूँ। ध्यान से देखो चल क्या रहा है। हमने फंक्शन कॉल किया, बोला नोड 1 से 3 जाने के लिए, है ना? 1 से 3 जाने के लिए फंक्शन कॉल किया, इसकी वैल्यू करेंगे 2 इनटू वैल्यूज पे मेरे को जाना है। फिर मैंने एक और फंक्शन को कॉल किया प्लस 3, जिसमें मैंने बोला अब मेरे को कहां से कहां जाना है। फॉर एग्जांपल अब वाया 2 जा रहे हैं, अब वाया 2 जा रहे हैं, एक ऑप्शन खोल दिया 2 से 3 जाना है और 3 की वैल्यू क्या है 1 है। एट द सेम टाइम एक और नंबर 2 चला रहे हैं, मैंने बोला ये ऑप्शन खोल रहा हूं इसके लिए मेरे को बार को जाने की वैल्यू है 1 है। ठीक है, ऑप्शन खोल किया इसके लिए 1 से 3 जाना है।
एक रहे देखो फिर 11 बजे मेरी क्लास है जो 11 तक की
समझ में आया क्या चल रहा है इसमें। This is our recursive function. इसमें अगर आप इसको क्या कर रहे हैं अपडेट कर रहे हैं। ये देखो
The first approach, we first transform the number of array into a binary. Either zeros equals to pi or every element by alpha is given by
उसको
0.
कोड करना शुरू करो।
Now,
description of a degree that
now our goal is to count all sub-arrays where one simple sub-array satisfies count. Let each modulo to store frequency of each prefix modulo.
ग्राफ मूवमेंट कैसे बनाना है ये आप लोगों को पता है। लेट्स सी
0. For I नम्स तक चलाना है, ठीक है, एक लूप नम्स तक चलाना है। हमने देखा कि अगर हमारा जो आई है वो फिक्स द कैंडिडेट अगर जो आई वाला है जो एक इंडेक्स है वो मॉड्यूलो के इक्वल है तो हम इक्वल बनाएंगे। अगर इंट जितने भी इक्वल हो रहे हैं अगर वो हो रहे हैं तो हम रन में डाल देंगे कि इतने इंट नीडेड इज इक्वल्स टू रैम माइनस के, क्योंकि के हमारा क्या है इसके बराबर होना चाहिए प्लस मॉड्यूलो। और इन सब का मॉड्यूलो करेंगे तो हमें सारे मिल जाएंगे जो नीडेड है। तो ना काउंट मिल जाएगा, बेसिकली इनका काउंट मिल जाएगा। और क्या कर देंगे मैप में काउंट हमारा काउंट प्लस इक्वल्स टू मैप ऑफ नीडेड। हम डाल आ रहे फिर क्या कर देते हैं कि जितने भी नंबर इक्वल है ना उनको हम मैप में बढ़ा दे रहे हैं।
जितने लोग ये बात कर रहे हैं आई विल चेक ईच एंड एवरी वन क्या कोड एडिटर क्या आपने कितना किया है। आई होप कि ये सब लोग कर
इक्वल्स हो जाएगा हमारा अपन एक अनऑर्डर्ड मैप बनाना है इसमें कि
फाइनल क्वेश्चन किया है
मैप का जो जीरो वाला होगा वो हमेशा वन होगा ऐसा क्यों
हमारे पास फ्रेंड्स उसका देन तो पहला वाला फ्रेंड्स मैंने पढ़ा उसका देन जो अगला क्वेश्चन है 20 सेकंड का पहला क्वेश्चन प्रेजेंट मोड का दूसरा क्वेश्चन
to handle cases where subarray starts from index 0 index 0 से start कर दो ठीक है if हमारे below is equals to k तो हम क्या कर देंगे इक्वल्स टू if अगर और हमसे क्या करेंगे रिमाइंडर इज इक्वल्स टू इक्वल्स मॉड्यूलस मॉड्यूलो जितना भी होगा ठीक है इतना ही बचा एंड कर देना हर बार कैलकुलेट करेंगे और नॉट नीडेड इज इक्वल्स टू रिमाइंडर माइनस के माइनस मॉडल आई एग्जीक्यूट चाहिए है बिल्कुल आई डोंट इवन नो क्यों करना है मैं मॉड्यूल अगर क्लिक करा और मैं काउंट प्लस इक्वल्स टू मैप से हमने नीडेड की वैल्यू निकाल दी काउंट प्लस इक्वल्स टू नीडेड और हमने मैप के रैंक को मैप के रैंक को बढ़ा दिया अब जो भी
आपको डायरेक्शन स्पेसिफिक क्रिएट करना है कि आपको कैसे जब इसको इंप्लीमेंट करोगे इसको फिगर आउट दे आर सर्टेन
किसका है दिल का इंतजार में रुकना, देख लो इधर तो एक बार ट्राई को yes I know Let's get it. Let's get it. Let's get it. Let's get दिमाग में बस एक ही चीज आती है जब बस बातें कर पाते तो सहन कर पाने पर जब हम जिसे बाकी जिसे किसी को जीवन कॉलेज में कंडोलेंस भी I just love the way that you shine on me. The way that you shine right now. Cause you're gonna lie. It's a little bit speed. Just wanna cancel it. But you don't say cancel man. I know you're mommy. Could not you just cancel it. Cause it's not easy. क्या करना था Each number of 1 to n is grouped according to the sum of its digit and the number of groups that have the indices. N is equals to 13. Pass. Teacher n. Each number from 1 to n is grouped according to the sum of its digit and the number of groups that have the largest.
Those who are done, we are done for the next week. Tomorrow at वैसे एक बच्चे ग्राफ कल बाकी सब ग्राफ कंप्लीट हो गया तो किसी के सरप्राइज टेस्ट ये ले लेंगे सरप्राइज टेस्ट ऐसा होगा नहीं पहले पेपर दिखाएगा सामने भेज दी होती है वो सरप्राइज टेस्ट उसके लिए यार
That is not just the size. Largest group एक से रिश्तेदार का और हमें देखना है कि उनका डिजिट सम बराबर है
Accidents utina yung particular largest group on that there is a world to हमारा largest हुआ अब इसका हम काउंट करेंगे जो भी हमारा मैक्सिमम काउंट मैप है इसका साइज मैप है जिसकी वैल्यू हमारी हमारी जो वैल्यू है वो बड़ी है बराबर होगी अगर एक्सेस सर्विस से कर लो काउंटर्स में सब आप जितने भी हमारे मैक्सिमम ग्रुप को नहीं उतना वो किधर भी हो लगेगा और इसमें से ठंड भी हो गई ये सर्वर के लिए खाना बने के लिए सर्वर वाला ये ठीक है तो ये क्या सोचा सबसे पहले हमें पता है कि लेक्चर है एक आगे चल रहा है के लिए चल रहा है और एक वैल्यू स्ट्रीम ठीक है इसका मैच तो होगा वहाँ भी और नीचे नहीं पता बहुत नहीं हो रहा है वो नहीं बनना नहीं बचा क्या लगता है अब अपनी ऑलरेडी गया फिर हमने फॉर लूप से लोग रीच and as a level basically but so get चला गया कॉल कर रही है आने वाले का डिटेक्शन करना strategy. So I'm going to use it. Spin around. Yes, and then you can still like to set cards. It is something it is something to be who can remember plus you medicine days. Nothing better than working on the max water with that the curve it goes yeah it takes personally I'm not so given this matter it's you secondo mi stavo parlando prima con la sua storia e va di risultato anche dove grande tanto mi sono fatto per un che ciao nella danza per me perché ho fatto questo andavo a fare la roba guarda che posso dire allora fai balance per fai resi non per fai stare sta poi ho preso un'idea voglio fare cioè sempre fare che vai di poter muovere perché altro questo è servi vecchia faccio fare di casa mi sembra che però recensione recensione some peace with yeah when we just right
and submit on that's a straight discussion. What as it is? No, that's the teaching. That's honest. That's a kind of it's yeah, because that I think the for was leaving them. है कि आखिरी महीने जो इंडिया उसको निकालने है तो महीने हुआ equals to and standard का उसको डिजिट करेंगे जो कि हमारा सवाल है so मतलब लॉन्ग की बात ये काफी अच्छा अच्छी no constants Java PD it's not more than it's being much aware as well when the ordered home बहुत ज्यादा पता है यही चल रहा है अभी करेगा इसको इसीलिए आपका वो जो बैकएंड कर रहे हैं वो तो कर रहे हैं वैसे अभी तो ज्यादातर वही कर रहे हैं तो प्राइम में लोग भी पर ये कि इंडस्ट्री में अभी भी जावा काफी निकल रहा है वाली कंपनी next after something navigating इसमें तो अरे ये होता है ना कि एक प्रोडक्ट होना है स्क्रीन होता है तो ये अपने आप चीजें ऐड करना होगा इसके जो जो होते हैं उन्हें इग्नोर कर सकते हैं क्योंकि ये अभी मेरे को पता नहीं है सब क्या है मैंने किया है। Start speaking. तो मेरे में hello small it's fine it's fine
ठीक है। अभी तक 10 नहीं चल रही मैं जो मतलब 6 बजे ऐसे नाश्ता में आता हूँ ये चीज़ें सर 4 बजे को डर बजता है हमें मतलब लगे खाना कैसा है financial ठीक है मुझे क्या मिला था उसके बाद करके देने को करके स्वयं आओ que खाना हुआ
Myself, Dr. Rajiv Mishra from IIT Patna. The topic of today's lecture is enabling intelligence at the edge layer for Internet of Things. So in this lecture, we will be covering the following topics. First thing is that you will be understand to know the issues in the traditional IoT platform. Then you will also come to know how the edge machine learning addresses these issues which arises in IoT platform, that is in the traditional form of IoT. Then we will introduce you to the workflow of edge machine learning, the advantages and the application of edge machine learning. So these are the use cases, or these are the topics which will enable you to understand the use of machine learning for IoT. So that is called an edge machine learning for Internet of Things. Let us recapitulate about the Internet of Things. So Internet of Things is a network of internet connected devices, that is called IoT devices, which embedded in everyday objects. This enables sending and receiving of the data to the cloud, such as the settings, configurations, and telemetry. So look at this particular use case or the example, that these are the different things which you can see over here. That is, whether it is a car or a vehicle, you have a mobile phone, or you are moving on some a river over the ship, or you are having a garden or a flower or a robot arm. All these are different devices which are embedded with the internet connected devices. They are called IoT devices. So Internet of Things is the network of internet connected devices which are embedded in everyday objects that we have seen, which enables sending and receiving all the data to the cloud, such as the settings and telemetry, etc. So we will also recapitulate about the traditional IoT platform, where these are the things or Internet of Things which we have now discussed. That is the network of internet connected devices, whether it is the sensors or actuators. These are specific things which we are now interested as the IoT devices. So in the traditional form of the platform, or in a classical IoT system, earlier days, you can see that these things or Internet of Things, they were directly connected for computations to the cloud. So you can see this kind of connections is happening to this particular cloud. This is an example of a cloud. And inside the cloud that we have already seen in an IoT platform, the data which is sent from the IoT devices will be used for three different use cases. The first is that after ingesting the data with the help of a cloud gateway, then the next step would be that this particular data is now processed. And so after processing, it will gain the insight into the data which is brought by the sensors, which are embedded in the everyday objects. So these insights will be now given to the business intelligence for making the decisions or the actions based on the policies. So these are the specific use cases whereby these things or Internet of Things are directly communicating to the cloud. They are dependent upon the cloud. So that is what is written. Let us understand it. Once the device, that is that is IoT devices connected to this cloud platform or an IoT platform, then it will be able to use different custom code or modules which are there, which are running inside the cloud. So that is, it will be in the form of capturing or ingesting the incoming data, and then now it will be sent for doing the insight using the custom build modules, and then it will be now will be used another module to manage control and to get the source or the details out and display on the dashboards. These are some of the actions of the reports, and these all things are covered under the insight. So this computation is performed directly by the cloud in the traditional IoT platform system. Now let us see what is this limitation. Although it has the advantages, but it has some of the limitations. That limitation comes in the form of a poor internet connectivity. So if the internet outages are there, then this particular cloud connectivity will fail. Hence, the insight or the actions which are dependent upon the cloud computation will no longer be accessible. So it's not that all the time internet connectivity is there for IoT devices. Then you have another aspect, that is lot of data has to move from, because it's not only one or two IoT devices, it's hundreds and thousands of IoT devices which are embedded into the daily objects. So these devices are now pushed into the cloud. So so much of data is to be shipped to the cloud for getting the insights. So this is a issue where too much of data is being slammed into the cloud and they dependent upon the cloud services all the time, and also the internet connectivity. This is another problem. Third problem is that, which is happening in the traditional IoT system, IoT platform, is for real-time responses. As opposed to the near real-time responses, we cannot get by sending the data to the cloud to find the insight and sending back the action. So therefore, this particular delay or the latency is due to the round trip time from the device, or you can also call it the ping, to the cloud. So sending the data for getting the insight, and then actions are to be now taken or being communicated by the cloud is taking a lot of time. And some of the applications cannot wait for that longer duration. Therefore, not many applications are supported by the traditional IoT platforms. So this particular drawback is due to the sending the IoT data, that is the things, to the cloud, and most of these insights is happening with the help of machine learning. So to perform the machine learning into the cloud, the data has to be sent back to the cloud, and then cloud has to report about the actions. So these kind of situations are happening in the remote control or a remote monitoring type of situations. That means if you want to do a remote monitoring or a control of an industrial situation or industry or a specific machine using this IoT or the device which sends the information, and waits for actuators are waiting for the response out of this insight, or merging the remote data across multiple IoT devices, that is aggregation or near infinite storage to train the machine learning models and other advanced machine learning models. So this particular data, not from one sensor but so many sensors required to be aggregated, and this data is to be stored somewhere into the cloud, and then the machine learning algorithm can be performed. So we have seen the drawbacks of this particular model. So what is the way out is performing the machine learning very close to the device, that is called machine learning on the edge. So what are you gaining? So you are gaining the following advantages: that it will be a low latency tight control loop near real time response if the machine learning is being performed on the edge, that is very close to the source, not on the cloud. Also, the sensor data will be now pre-processed on premise, need not have to send everything to the cloud. Third important thing is that you can do the intelligence to get the insight. A pre-processing of machine learning is to be performed at the edge, and if let us say that most of the task is completed, need not have to go to the cloud for this purpose. Similarly, if there is no connectivity between the edge and the cloud, that means that edge can also work offline to support the offline operation. That is also possible if, let us say, machine learning is being done at the edge. Finally, the data need not have to send directly to the cloud all the time. Therefore, data privacy and IP protection, all that is being met. So therefore, nowadays, you know that doing machine learning on the edge will add a layer of edge that is called, for IoT, that is called an IoT edge, is to be added in between this particular IoT and cloud. So this is the model which we will discuss. Also, we have so far briefly mentioned in the previous class. So what we are going to see today is that bringing the machine learning to the edge for IoT. So therefore, you can see that earlier slide, things was only having that the devices, but now the things is now populated with the insights, which earlier also will be done only by the cloud, and taking the action also can be performed at the edge. So this kind of edge is now adding up the capabilities which, or it mimics the capabilities by edge. You can see here that these are the capabilities which earlier used to be performed at the cloud, which is now enabled to be performed at the edge. So if you are doing the machine learning to get the insights, so machine learning inferencing will be performed at the edge for doing the IoT. So here, once the IoT device fetches the workload description from the cloud, then whenever the device receives this deployment manifestation from the IoT service, it will understand that. So these are more details about how this insight and action you can run in the edge as well. We are going to discuss this in more details about this development. Now, enabling intelligence at the edge layer. This is the topic of today's lecture, after clearing up the background of simple IoT platform. So enabling the intelligence at the edge layer for IoT is the topic of this particular lecture. The idea is to manage the increasing amount of data that is being generated by the devices, that is the sensors and the actuators, which is to be sent to the cloud for doing this kind of business intelligence or performing the business logic. Now you can do the same kind of business logic at the edge instead of the cloud. Therefore, if data do not have to send to the cloud, you will achieve a low latency, that is the delay will be not there, and also have a faster response time for IoT devices if you perform the machine learning at the edge. So we are now here that the theme of this particular session or a lecture is enabling the intelligence at the edge layer for Internet of Things. Now let us understand by how are you going to enable the intelligence at the edge layer for Internet of Things. So for that we have to understand what the edge layer has to deliver. That is how the edge layer is going to mimic the capabilities of a cloud services. So edge layer will be delivering the three essential capabilities. One is that it will enable the local data processing at the edge. Second thing, this particular capability of edge layer will be to filter the data transfer to the cloud. That is, it can do most of the job at the edge, but whatever it has to be supported only by the cloud, only that data will be filtered and then transferred to the cloud. Third important thing is that the business intelligence or the logic itself runs over the edge. Therefore, it will enable the faster decision making. So let us see all these three different essential capabilities which are to be enabled at the edge layer, how that is all being supported. So the first thing is supporting the local data processing is an important capability of enabling intelligence at the edge layer for IoT. So in order to deal with the increasing amount of data which is generated by the sensors, most of these business logics are now deployed at the edge layer instead of the cloud to ensure the low latency and faster response time. So that these business logic are जीरो से नाइन तक कोई भी आ सकता है एक लाइन पे एक सिंबल होना चाहिए नो ऑब्जेक्ट वन ऑब्जेक्ट टू ऑब्जेक्ट थ्री ऑब्जेक्ट फोर इस तरीके से नाइन तक कुछ भी आ सकता है और अगर इनिशियल से जीरो से नाइन तक आप कुछ भी मिलता है आप उतने स्टेज जाएंगे जैसे ये स्टेज आपकी मर्जी है और स्टेज ये या आपको बोल सकते हैं इंटीजर जो आपको प्रिंट करना है अब हो सकता है इंटीजर की लेंथ 1 हो या उससे ज्यादा हो और इससे ज्यादा होगी तो क्या करेंगे एक लूप लग जाएगा इसमें सेल लूप से 0 से 9 तक और ये आपकी फाइनल होगी या नहीं ये इंटीजर को आपको एक्सेप्ट करवा देती है आपकी क्या होगी फाइनल स्टेट सबको समझ में आया नहीं 0 से 9 अगर कोई सिंबल आता है तो आपको फाइनल में लेके जाएगा उसके बाद अगर एच क्या है एक से ज्यादा है तो उसमें लूप लगा देंगे इस तरीके से 0 से 9 तो इसको करेंगे नाउ सी तो उनको किस तरीके से इंप्लीमेंट करेंगे अब नोट का ये पार्ट है हमारे पास ये जो पार्ट है हमारे पास ये तो इंप्लीमेंट कर सकते हैं आप जबकि हमने हमारे पास ये इंप्लीमेंट है पहले से ही और अगर 0 से 9 आना है केवल क्या बात इंप्लीमेंट नहीं है inside of that particular data which is generated at the edge layer will be now then fed with the business logic which is also running at the edge layer and this both together will enable the local data processing. Only the subset of the data which is generated by these sensors need to be sent to the cloud after aggregating and filtering of the data at the edge. Now second important capability is to filter the data transfer to the cloud. So this particular edge computation that is called edge computing approach significantly saves both the bandwidth and the cloud storage. So important thing is that this will enable the faster decision making. So you can see that this AI enabled new capabilities for the edge computing will enable the decision making and the advantage is in the form of doing the artificial intelligence at the edge layer. So doing the artificial intelligence at the edge layer is the perfect place for deploying machine learning model which is trained in the cloud. For doing this inferencing, that is taking the business decisions or taking the faster decisions. Now let us see more detail about this kind of IoT edge platform. So there are two things. One is called performance, the other is called cost. So performance versus cost trade-off. Let us see how it reflects in IoT edge platform. So you can see that the machine learning implementation on the edge heavily depends on some specialized processors. That you may be knowing that these processors these are often very much needed in the cloud that complements the CPU. That is, no conventional CPU can increase the speed of training the machine learning algorithm. So how are you going to get these specialized processors enabled at the edge? So to bridge this gap between the cloud and the edge, these innovations in the chip design offers a purpose-built-in accelerators that speed up the model inferencing at the edge significantly. So you can see a lot of chip manufacturers such as Qualcomm, Nvidia, ARM, they have launched a specialized chip that speeds up the execution of machine learning enabled applications. And they have also reduced the form factor so that they can also run at the edge as well. So the edge now can have the GPUs also, so they are in a small form and also they are cheaper. And this particular innovation has led to this kind of edge computing or edge layer. So therefore, these modern processors, which is called GPUs, will assist the CPUs for the edge devices by taking over the complex mathematical calculations which are needed for running the machine learning models such as deep learning. And therefore, these accelerators will accelerate the inference process. So this result in a faster prediction, detection, and classification of the data ingested at the edge itself. So the solutions like Microsoft Azure IoT, Edge, Runtime, and Qualcomm Neural Processing SDKs for making the machine learning possible to take these models trained at the cloud, but they are now running with the hardware accelerated inferencing at the intelligent edge. So how are you going to make this intelligent edge is the following way. First thing is that these GPUs, they are also called the accelerators, are now available for the edge layer. And this is due to the innovations in the chip design. So once these accelerators are available at the edge, so that machine learning model or AI model which are trained in the cloud can do the inferencing with the help of accelerators like GPUs at the edge. So this is what we are going to see, that due to the reduction in the cost of these specialized processors, which the chip designers innovation has brought into the use at the edge layer also. So the important chip manufacturers which manufactures GPUs which will run in complement to the CPUs at the edge layer is used to do this run the inferencing which of the AI models which are trained at the cloud. This will enable this particular predictions, faster predictions, object detections, image classification of the data which is ingested at the edge layer by the sensor nodes. Now this is therefore moving forward with the IoT data and performing this machine learning on this IoT data. Now, as far as machine learning process is a two-stage process. One is called training, the other is called inferencing. Now, training requires huge data set and lot of compute power. Therefore, the training is itself confined at the cloud or it is at on-premise servers. So you can see here in this particular figure that the training part of a machine learning data which is of a machine learning on a data which is now generated by these particular sensors or an IoT data need to be trained at the cloud. That is called the training. So training means learning a new capabilities from this kind of IoT data. So this has to happen at the cloud or on premise. Why? Because it needs more resources. So this particular training requires a specific deep learning algorithm or a framework and the data set called training data set. And this, you know, that these two things requires a huge storage in the form of the data warehouse. This storage will feed this data set into the deep learning framework and this will generate a trained model. Now this trained model, if it is deployed or shipped to the edge, now then edge device now can work in conjunction with the cloud. So therefore, once this trained model is deployed and run on the edge, then the other part of the machine learning can happen at the edge itself, and that is called the inferencing. So when a new data comes for prediction or the inferencing, that can happen on the using the trained model over the edge, and this CPUs along with complementing the CPUs, the GPUs are also there with the edge, and therefore inferencing can happen. So this particular capabilities are now possible with the innovation in the new kind of chip manufacturers and a new kind of technologies which are now possible, which has made this possible to run the GPUs at the edge layer. So let's see that these kind of discussions which I have described in the form, which explained with the help of this diagram, let us see that the training which involves the use of deep learning framework, and this is often the TensorFlow based deep learning model or a framework which we are talking about, is used to train the data set. So IoT provides the source of training the data that the data scientists and engineers uses to train the machine learning models for a variety of use cases such as failure detection to the consumer intelligence. So here the data scientist is required here to, after the IoT generates the data, it has to build into a data set which is to be fed to a deep learning framework, that is a TensorFlow based model for training and running that particular business intelligence from the inside. So for that you require inferencing. So inference refers to the process of using the trained machine learning model algorithm to make the prediction. So IoT data, then if it is presented to this trained machine learning model, it will enable the predictions, and that particular prediction can guide the decision logic at the device itself, at the edge gateway or elsewhere in the system, makes this inferencing very faster and usable for the modern applications. So going beyond understanding how that is possible to run the machine learning on an edge IoT. So this is the topic of this particular slide. So here you can see that machine learning on edge IoT, how that is all being done. So to do this machine learning on an edge for IoT, we have to touch many aspects of a general machine learning workflow. So this particular slide or this lecture is not intended to present an in-depth understanding of machine learning algorithms, but nevertheless, we will be able to make the understanding here, the people who do not know much background of the machine learning, to understand how the machine learning can be implemented over the edge in this lecture session. So we intend to illustrate the process of creating and using a model for IoT data processing with the help of machine learning. That is what we are now intended here. So for this, we have divided this particular process flow of doing machine learning on the edge in 5 different steps. First is to collect the training data. Second is to prepare and do the experiments. Third is to deploy the trained model on IoT edge. Fourth one is to run the model and get the data. Fifth one is to maintain, that is to collect more and more training data, upload to the cloud for retraining and improve the model over the time. That is learning and relearning and so on. So let us see all these steps in a more details. So the first step is to collect the training data in this particular method. So the process will begin by collecting the training data. And you know that the data, we mean that it is the data which comes from the sensors. So in some cases, the data has already been collected. That is called historical data, and is available in the database or in some data files. Or in other cases, especially for the IoT scenarios, the data need to be collected from IoT devices and sensors, and now then it will be stored in the cloud and then make it usable for doing the machine learning. So the first step is to collect the training data. This particular figure is explaining that this IoT device, that is the sensor data, will now send this particular source that is data ingested into the Azure cloud storage and will be stored in some databases. This is the first step to perform the machine learning on the edge for IoT. The second step is to prepare this particular data, and it can be usable for doing the machine learning experiments. So this raw data, as it is collected from the devices and the sensors, need to be prepared so that it can be used to build, it can be usable for the machine learning algorithms. So it requires the data preparation. So that is called the raw data. Raw data is not usable by the machine learning if it is once it is collected from the devices, requires a step. So this step is very much essential to prepare the data so that it can be used for the machine learning. So this step may involve data cleanup, data reformatting, or pre-processing to inject additional information. Machine learning can use it. So that is called a data preparation, involves all these explicit labeling for every data point in the sample based on the actual observation. So it requires the domain expert to prepare this particular data. It often needs the domain expert and the data scientist. So here comes the role of a data scientist in preparing the data, which is now usable for the machine learning algorithm. So this information allows the machine learning algorithm to find, once it is done, then this particular data set will be usable by the machine learning algorithm to find various correlations between the actual sensor data pattern and the expected result. And this, you know that this stuff is highly domain specific, so data scientists are needed. So let us see in this particular figure. So what do you mean by preparing and doing the experiment is to train the model using Azure machine learning. So here you can see that the data which is stored will be now made into the form which is usable by some machine learning, and so this is all happening into the cloud. So using a particular machine learning algorithm, the machine learning model is being generated or is called machine learning model. Now the next step is to build a machine learning model. Is to build a machine learning model is based on the data which is prepared in the previous step, and you can now do the experiments with different machine learning algorithm and the parameter to train the model and compare the result to one another. So you can see which machine learning algorithm is doing the best job for running the business logic. So in this case, for testing, we have to compare the predicted outcome computed by different models with the real outcome for an observed for an IoT application. So Azure machine learning, this can be done in a different iterations of the model that is created in the model registry, and here this is shown over here that the model which is trained in the previous step is built with the help of a machine learning algorithm and the prepared data set, and this will now generate this trained machine learning model. This icon is showing that it is the trained machine learning model which is generated at the cloud. Now once the machine learning model is available, then you can deploy the machine learning model at the edge. So based on the prepared data, you have now parameterized and got the trained models and this particular model now can be deployed on an IoT edge. So use this particular model so that it can be now running at the IoT edge to predict various kind of actions or the events which is very much needed for the business logic to take the decision. So that is what is shown here in this particular slide. This is the trained model, and often this particular trained model is running now at the edge layer. So this is if it is the edge layer. So what it will do the inferencing in most of the cases, but in some of the cases where the data which is not having the good accurate result and need the machine learning model to be retrained, that particular data will be sent back to the cloud for retraining and this rebuilding this particular trained model on the machine learning. So maintain and refine the model so that our work is not done once the model is deployed. In many cases, you have to continue collecting the data and periodically upload it to the cloud, and you can retrain and refine your model. So this is an iterative process. So when we can redeploy to the IoT edge and the entire ecosystem is shown over here, that you know that this particular data after now going through this particular inferencing from this particular model, and the edge decides that this data has to be sent after filter. This IoT data need to be sent to the cloud, and and it will be aggregated here in the storage, and then it will be used to retrain the model. So retrain model is again updated. So that is what is written over here. You have to keep on refining the model at the edge, and this is the way. So therefore, you have to collect more training data, upload to the cloud periodically, and improve the model over the time. And this is all done intelligently with the filter at the edge. So now we are going to see how software as a service, which is being provided by different cloud providers, how this edge machine learning platform is being supported by them. So here you can see in this workflow that this particular cloud, how it is going to offer this software as a service for edge machine learning platforms. So one such example here is from Microsoft Azure IoT Hub, which is running in the cloud. So some of the modules which are running inside as a part of Azure IoT Hub, they are called custom code, which will perform the data transformation. Then second one is called Azure Cognitive Services, which is used for getting the insight. Third one is called custom code, which is second question लिखिए आप design a real page index code. Design a real page index code. Over sigma equals to a comma b. Which contains set of all possible strings where every string
is used for the action. So let us see that once the edge device is connected to the Azure IoT Hub service, now these custom modules are being developed. One to capture the incoming data, that is called here. So incoming data from these particular devices will be captured.
start with
It is also called data ingestion if the volume is more. If the volume is less, then using telemetry MQTT protocol is used. If the volume is more, then this data will be ingested using some of the open source like Kafka. So the first module will capture the incoming data and will send to the custom modules. So these are the custom build module to take the decisions or to take the actions. For that, it has to use the insight. For that, it uses various other services. Now there are many other services which are used to manage and control to get the score out of the display of this particular model, and we are going to see this in more details. So the entire system of doing this particular data ingestion, insight, and the action which is happening in the cloud is being offered the software as a service to for this doing this HML platform. Let us see in more detail how this particular services which are running in the cloud using the software as a service platform, it can afford this HML. So for this, the first step is the containers. So these particular modules which are running inside the cloud now offer containerization in the form of containers. So the data transformation is packaged or is containerized. Similarly, the insight is also containerized and the action is also containerized. So therefore, this is the first step is that it will package the data transform insight and actions into the containers. This is called containerization. Now then you have to write these modules and package them into the Docker containers. So let us see. This is the next step. So if you package it into the Docker container, so it will require to be registered as a container registry. So all these containers are now registered. So what it says is to push all those Docker container into the container registry, and having done this, then this will define the workload description into the cloud. Then write a deployment manifest, which is also called the workload description, that deploy these three modules. So these three modules are now packed into the workload description into the cloud, into the Azure IoT Hub. Now this workload description, which is containerized using Docker container and is available with the Azure IoT Hub in the software as a service SaaS model, will now make this available to the edge layer in the form of IoT edge runtime. Will use this workload description. So the target IoT edge runtime on the edge device. So the edge device is running its runtime that appear because it's right hooked to the specific instance of it. So you see that the IoT edge runtime will receive this workload description in the form of Docker and container, will facilitate this migration or movement or deployment into the edge. So therefore, this particular modules, one is data ingestion, second is insight, third one is the actions. They are all containerized and is available as the workload description. And then using the Docker container, it will be now migrated or is deployed into edge using Docker container. So therefore, this workload description will bring into all these capabilities, which this cloud is now happening. So therefore, shift the workload description to the target IoT runtime on the edge device. So this is the edge device. So the device receives this deployment manifest from the IoT Hub service. It understood that it should go and fetch these three containers. So these three containers described in the workload description from the container registry will be deployed. So that you can see here, enabling the edge with these capabilities. So the target edge runtime download the correct workloads from the cloud and then start using the container registry and runs it on. So all these containers will now start running these three different capabilities, that is data ingestion, insight, and action, which earlier cloud used to do to the local device. Now let's see the entire picture that is being defined here in Azure IoT Hub. So Azure IoT Hub allows bidirectional communication between the cloud and IoT devices. It also allows the developer to take advantage of the information to provide insight, monitoring, and develop custom solutions to the IoT platform. So here it is quite explained that these IoT devices, which is equipped with the sensors and actuators, will send the data that is called sensor data to the Azure IoT Hub, and Azure IoT Hub will perform the insight, monitoring, and using different applications. Now this Azure IoT Hub will use the software as a service and therefore will enable the computation to be done very close to the devices, that is called the edge, and rest of the things will be performed by the at the cloud. So the machine learning model will be performed, training will be performed by the cloud, whereas the inferencing will be performed at the edge. And this particular capabilities will allow the data to be transmitted back and forth between the devices and this particular software as a service, that is whether it is edge computing or a cloud computing. So therefore, let us understand the key characteristics of such software as a service IoT edge platform, which is being provided under the software as a service, which is called Azure IoT Hub. So Azure IoT Hub is a software as a service platform and which enables the edge layer and a cloud model to facilitate. So therefore, this particular software as a service, that is called Azure IoT Hub, or you can say Edge IoT or IoT Edge, is used to manage the services for bidirectional communication. So it is managed service for bidirectional communication between the cloud and the IoT devices. So it is a platform as a service. So it is a platform. This we are talking about this as the Edge IoT Edge platform. So it is a platform as a service offering in the Azure for IoT development. It is highly secure, scalable, and reliable, and it integrates with a lot of Azure services. Programmable SDKs for popular languages are available, and it also supports multiple protocols such as MQTT, HTTP, HTML, sorry, HTTP, etc. So let's see more characteristics of such IoT Edge platform, which runs as a platform as a service. So there will be a camera module. which handles the scanning if the camera is a device as an IoT device. Then it will also use another module which is called text to speech, where the microphone is the device as the IoT device. Similarly, the IoT Azure IoT hub are used to manage and deploy using these Azure IoT hub edge devices. So there are various services which are being offered by this particular type of platform as a service that is called IoT Edge platform. You can have the microphone, you can have the camera as the devices, and therefore this IoT the edge devices will have the support of data ingestion and performing the insight and the action for these kind of devices with the help of Azure IoT Edge runtime. Similarly, this Azure IoT runtime is being supported by the cloud, that is Azure Cloud Services, that is a software as a service for this particular edge device, that is Azure IoT Edge runtime will use this Azure Cloud as a software as a service. So this entire thing, this edge will be offered as a platform as a service, whereas this Azure Cloud Services for this IoT Edge runtime will be offered as a software as a service. So Azure IoT Edge in action, you can think of that. You can use this kind of software as a service to develop your container workloads, upload your modules in the container registry, do the provisioning of these device agents, select the device deployments, define the modules, and then define the message routes and define the model parameter. That is what is shown over here. So all these things we have already explained, and these features are available to the developer. So Azure IoT Edge, other functionalities is that it will target the workload to the correct type of device. It will create the workload which can include high-value machine learning and run those workloads locally, even in the disconnected manner, and monitor the health of the workloads. So the advantages of edge machine learning is that the first advantage is it facilitates the reduced latency. That is, the transfer of data back and forth from the cloud takes a lot of time, and therefore this introduction of edge layer, which uses the machine learning computation locally at the device level, reduces the latency. Second important advantage is the real-time analytics can happen using the advantage of edge computing. Third is the high speed, so the data is processed locally and need not have to send to the cloud. So therefore, a higher speed of inferencing or insight is possible here, and it will also reduce the bandwidth requirement because not all data need to be sent to the cloud. It will also improve the data security. Other advantages are scalability, improved reliability, reduce cost, and reduce power. Most important out of this is that first, that it is scalable. So this particular platform or the services will going to support large number of devices. Therefore, HML typically processes large amount of data, and if you have the big data source like video images coming from various sources simultaneously transferring to the cloud is now not required. So it will be also having the improved reliability, higher level of security with a greater speed will bring into the reliability, reduce cost is also there, and reduce power is there. There are various applications that are awaiting for this kind of IoT edge and machine learning platform in the manufacturing, in the energy sector, in the industrial IoT, autonomous vehicle, healthcare, and smart homes. So autonomous vehicle is the perfect example. What we mean by autonomous vehicle is the driverless car, self-driving cars. So self-driving car, that driver is not there. So they're using camera. These particular devices used to sense the environment, and it has to take the decisions whether to move forward or to stop, or what is speed, and this computation has to be performed within the milliseconds, which cannot earlier possible with the help of cloud. So with the help of this HML, this autonomous vehicle is a new kind of applications is possible. Similarly, the healthcare, the patient monitoring device has to now deliver the prescription or the decision for the patients, whether it requires immediate attention of medication. Similarly, smart homes and all these are the new kind of. Similarly, the industrial application, so monitoring all the devices of the machine and the inspection with the human is not possible in some of the situation to know then when the machine is going to stop functioning unless it is put on the repairs. So let us summarize this entire lecture that we have brought into the limitation of an IoT platform. IoT platform, classical IoT platform comprises of IoT and the cloud. So IoT data is directly sent to the cloud. That has a lot of limitations. Therefore, the edge machine learning is possible. Now we have seen with the advent of a lot of innovation in the chip manufacturers, this particular HML is a possibility, and therefore this limitation of IoT platform is possible, is overcome from this introduction of the HML. We have seen how the edge machine learning, how the machine learning at the edge is possible. The entire workflow we have discussed here. We have also seen the advantages and the applications of HML. So with this, we conclude this lecture. Thank you. I am Dr. Rajiv Mishra from IIT Patna. The topic of today's lecture is ML-based image classifier at IoT Edge. In this lecture, we will cover the following topics: basics of computer vision in machine learning, different techniques of computer vision like image classification, detection, segmentation, object detection models like RCNN, faster RCNN, so YOLO, SD, SDD, and so on. Then we will look into the computer vision from Azure, that is how that is being supported as software as a service, SaaS. So let us give an introduction to the computer vision. So as you know that computer vision is a sub branch of machine learning, and this deals with giving the computer the ability to see and interpret and extract the information from the images and the videos. So the videos can be seen as a collection of images. So here in this particular figure, you can see there are different objects which you can see in an image. So how to interpret whether it is a bottle, or it is a laptop, or some bowl, or it is cup, or it is a bag, chair, and so on. So this particular ability is quite natural in human beings, but how this capability is to be enabled into the machine using the concept which is called computer vision, and that can be enabled with the help of machine learning. And for that, we are going to discuss some of the preliminaries and the basics, and then we will see how these capabilities can be enabled into an IoT edge. So let's understand a bit deeper about computer vision, its working. Now here, to train the computer vision in a machine learning model, you essentially need to feed hundreds and thousands of images of interest. So for example, if you want to find out in an image whether it is a cat or it is some other animal, so you have to now get such images as an example of a cat or some other animal. So these particular thousands of images will now be used as the data to train the computer vision model. For that, this computer vision model will apply some complex mathematics and feature extraction to find out, in contrast, what is the background and what is the object into that image. So based on that, the model learns the key understanding or the properties of the objects that defines the cat or some other animal and distinguish that this is the basic understanding of the computer vision. And it mimics the way humans can also understand it with the help of their vision and understanding through the neural networks. The only difference here is that now instead of neural network, it becomes an artificial neural network that is being simulated into the machines. But the capabilities are means inspired from human beings. So take this example: you have the rich data set of thousands of images of a particular object, cat or animal, and this particular so many number of images of a cat will be fed to a machine learning model that is running that computer vision. That is the algorithm. This particular algorithm or a machine learning model for computer vision is trained, is called a trained, once it goes through all these particular images and understands the features of this object that is called a cat. So you can see the output. That means when a new image is given to the trained model, it will be able to detect with some percentage what is there into that image, whether it is a dog, it is cat, or it is a duck or a bird. These are different classes. They are called classes. Now you can see that if you apply a threshold, that if it is more than 90% probability of a particular class, then you can declare that this is an image of a dog and the other image is the image of a cat. So this is a simple way to understand how the computer vision with the help of algorithm and the data set works. So now let us see the other view, that is called the data analytics part, which is associated with this computer vision. So with every machine learning model, the model is not only the important part, the fundamental fact is that it is going to determine how good your model is the data which you feed to it. So therefore, this particular aspect, which is called the data science, is to prepare the data, or it is also called the data set. And this particular data set, if it is properly prepared by the domain experts and with the help of a data scientists, then your model will be performing very good. So therefore, there is another point that we have to focus on, the fact that your model is only as good as your particular data. It's not that machine learning model is doing good or bad, it is the data set which becomes a very important factor to train the machine learning model. And this aspect is called the data science. So to perform this computer vision, you have to have a good understanding of a data science, and those experts are called data scientists. Now, if you want to do an IoT, Internet of Things, which is enabled with this computer vision capabilities, then those people who are working for the IoT, they have to be a good understanding, or a data scientist working for an IoT. These are different job roles for this computer vision role. Now, this particular lecture will make you sure that how you can build your good data, how you can prepare the good data set, so that you can build a very good computer vision model. So here you can see that what we mean by a good data set is a data set which can train the model with a good set of examples is called a good data set. Now let us see what are the techniques when we say that you want to train the model, machine learning models for computer vision. What are the techniques which are needed for doing this kind of training? Before that, what are the techniques which are needed to get this computer vision working? So computer vision, as you know, that deals with all the problems related to the images and the videos, and you know that images comprises of pixels, that is in the digital forms, and the videos comprises of set of several images. So these are the fundamental principles has to be understood in the computer vision. So with the help of so many pixels in the images, you have to now decide whether the object in the image is a cat or it is some other animal, that is cat or a dog. So how to understand from these particular collection of pixels to get this object understood? So there are a lot of techniques or the fundamentals that can be tackled. The object in the image is a cat or it is some other animal, that is cat or a dog. So how to understand from these particular collection of pixels to get this object understood? So there are a lot of techniques or the fundamentals that can be tackled with the computer vision, and few of them include this technique which is called the image classification. So that means image classification means that the object which is built out of several pixels together is able to classify as the cat. So this is called the image classification. Then the next issue is called the image detection. So image detection means that in a particular image where that object is located. This is also sometimes called the localization. So classification, that is there is a cat into that image, but where in that image that cat locates, called localization. Now, to get this particular classification and localization done, for that you require to build a segment or segment that particular object into the image. This technique is called segmentation. So segmentation is that given an image, you have to now segment the image with a different color in contrast to the all other things in the image becomes the background. So that is called the image segmentation. Similarly, inside that image which is segmented, now you have to do the image classification. Then comes the next issue called pattern detection and object localization that we have already defined. So the object detection and image classification are the two things that we are going to discuss in this particular session, in this lecture. So we are going to go into some models. They are called predictive models. That means they will do predictions based on this object detection methods. So let's complete that for a single object. So far so good. But what about if let us say that your image has more than one objects? Whether it is having a cat, it is having a dog, and it is having a duck also. There are different classes of objects of your interest in your computer vision, and all the objects how they are going to be means identified, segmented, localized, and classified. All these things together is called the object detection. So if several objects are there, so all the objects are to be now identified, and this entire technique is called object detection. So object segmentation instance is also shown over here. For object detection, you have to segment the images. As I told you that there are different objects, so they are all segmented here in this case. So whether it is the single object or there are multiple objects, all these object detection techniques will be able to handle that. So these are the techniques which are very much needed to build a computer vision application. So let us see this. What are the architecture for computer vision? So typical end-to-end pipeline for computer vision architecture is that first you have to get the input data, that is nothing in the form of images of those particular objects which need to be classified first. These objects require a pre-processing. That means the noise part in the images need to be reduced. That object into the image or that image need to be scaled, and also sometimes requires to change the color. So OpenCV is the software now that is used for doing this pre-processing before this particular object becomes usable for the training of particular computer vision model. Then the next process is called selecting the areas of interest. That is to do the object segmentation and the object detection. That is this particular technique will be applied once the pre-processing of that particular data set is complete. Then the next part is that how to identify the features of the objects of interest. That is from extracting the data about the feature, and then based on this learning, the inferencing will be performed. That is about the prediction or the recognition. That is called object recognition and the feature matching. And finally, based on this, some action has to be taken if it is an IoT device. So the action could be that it will send some information to actuator. For example, if the IoT device is monitoring a particular traffic in the road and it finds that too many cars are there and almost a traffic jam, then the signal at the junctions has to work. That means this action has to be now fed to that. Particular junction. So therefore, these input data, which is very much needed for this computer vision, the images that you want to train your model, but these images might be coming from a lot of different sources. So all these pipeline will be used to build that particular data set in the computer vision. Now let's see how we are going to handle this pre-processing, which is very, very important. So the input data set to overcome from various issues, noise, scaling, and color changing, all this is being pre-processed in that raw data. So after pre-processing, you will get a prepared data, which will be fed for machine learning model training. So machine learning often depends upon the standardization. That means you need to pre-process the input image to make sure that they are of same size, so that the machine learning model for training will not find any issues. Similarly, there are some other kinds of noise while taking that image from the camera. So all that need to be dealt before being used in a data set for model training. So if it's not correctly done, the model might learn the noise part and also other features which are not good for image recognition or object detection, and therefore the flawed, the fundamentally it may go wrong and the model may not give the accurate predictions. So therefore pre-processing is very, very essential, and we have discussed this. Once the data is pre-processed, the next part is about the data scientists. They have to label the data. So what do you mean by the label? So that means if a picture of a cat is presented, so that label is attached, and this label will say that this is an image of a cat. So you require a domain expert to see the image and tell. Similarly, the data scientist also is required. So how many minimum number of images are needed to train the model? So these are the different things which is called the labeling your data. So for object detection, you have the images that is taken in different way of the same object, and if you have an image of a cat or a dog, you need to label that. That means train. You have to tell. Label means you have to tell the model that this is the image of a cat. So this label or the tag to the specific area where the dog or a cat is lying is essentially put as a label, and this needs to be done very well by. So this particular labeling is very much essential in a supervised learning. That is one part of machine learning which handles this computer vision, that is called supervised learning. So these supervised learning model require this data labeling, and that is of our interest. That is for object detection, and the image segmentation will require this aspect to be completed. That is called data labeling. Now feature extraction and prediction is the next step in that process of computer vision. So the feature extraction and the prediction part will be performed by the machine learning model. For that you require you have to finalize which machine learning model you are going to do to apply on for with the data set for computer vision. So these are the parts of the model training. So the model learns about the features which are present to distinguish between the cat and the dog, and it will extract the features. So if it is the deep learning, then these features are automatically learned. If it is a machine learning algorithm, then these particular data scientists, they have to now do a feature engineering and identifies what features are important to recognize whether it is classify whether it is a cat or a dog. And if the features are relevant in the images, then those features are learned through the pattern, and later the model uses it to build a sort of rules for itself, and these rules are then used to do the predictions when a new data set is given. So this particular part that is called feature extraction is a part of a machine learning algorithm to do this. Similarly, for prediction and recognition, that is also inferencing part. After the training, the model will do this kind of recognition, that is object recognition and feature engineering. So this part, feature extraction, is used at during the training process, and in the supervised, this requires a supervised learning. And then the next part, which is called the prediction or the recognition, this is called inferencing, and this is used to do predictions. So we are going to see these kind of things. Now let's see what are the different standard models which are now over the period evolved for doing this computer vision. So the field of object detection has gone to a tremendous transformation. We're coming from the earlier days of very low resolution and very low accuracy models using the algorithms. Why? Because it requires artificial intelligence or the learning based system, like which mimics the human beings, not the fixed algorithm which can learn all that details of objects. So therefore, over the last 20 years, a lot of innovations happened, and those models are now finalized and decided as the key building blocks for object detection in computer vision. So let us know them. They are called regional RCNN, fast RCNN, faster RCNN, YOLO, and SST, that is single shot detector. These models are now standardized and now put in the cloud, and they are now given as the service, that is the software as a service platform. They are running one of these algorithms into these kind of cloud-based services. Let us go one by one very briefly about them. Why? Because this is a very little background which we intend to prepare so that we will understand this particular lecture further in a great details. So RCNN is, let us say, that first model which you can use for object detection, which is developed. So RCNN, the full form is region-based convolutional neural network. So region-based convolutional neural network uses 3 different steps. One is that it will scan the image for looking up possible objects using the algorithm which is called selective search, and those kind of regions where there is a possibility of the object, so they will identify, and they are called region proposals. Then it will run a convolutional neural network CNN on top of each of these regions of interest, and then take this output of each CNN and feed it into a support vector machine to classify the region, and or a linear regressor to find out the bounding box around that particular object if that object exists. In other words, so the first proposed the regions and then extract the features and then classify those features for those objects. So in essence, these object detection uses this image classification, and RCNN is very intuitive and very slow because it has to first identify those regions of interest, that is called ROI, from the proposal method from the input image. So if the input image has 3, 4 dogs and cats, so for every object region of interest will be earmarked, and then so many number of, for example, if 5 regions are there, 5 different CNN will run on each region proposal. Now this is a duplicacy that so many convolutional neural network, if let us say image has many objects, so many number of convolutional neural network will run, and then the output of that convolutional neural network require a classifier. So that is, it is whether it is a SVM classifier, and SVM classifier will classify whether it is a cat or a dog, and then where that particular object lies into the image. So it also requires a regressor. A regressor means it will give the coordinates, height and length of that particular object. So that particular object, so therefore both the classifier and regressor will be attached after the convolution. So this becomes quite slow to classify this kind of images using RCNN. So faster RCNN is an improvement. So you can see here there is only one convolutional neural network, and using this convolutional neural network it will scan and identify the regions of interest, and for every region you will be having the fully connected layer, and this fully connected layer will now do the both the classifier and the regressor. So this becomes faster because of the fact that so many convolutional neural network CNN is not required. Only one CNN will do that. So therefore, this improvement is called the fast RCNN. So fast RCNN performs much better in terms of the speed, but there was one bottleneck remaining, is that the selective search algorithm for generating the region proposal was not efficient and therefore led to the faster RCNN. So let us see that faster RCNN used to replace the slow selective search algorithm with a fast neural network. So it introduced region proposal network. So this selective search algorithm along with that region search together is called region proposal network, RPN. So here you can see that after the CNN doing this scan, what it will do, it will identify those selective search using region proposal network. So these region proposals network will contain a region of interest, and then with the pooling layer, then it will go ahead for a classifier and a regressor. Classifier will classify the object, and regressor will then bound a box on top of it. So let us see, the unique thing about faster RCNN is region proposal network. So this, in the last layer of the initial CNN, the sliding window moves around across the feature map and maps it to a lower dimension. For each sliding window location, it generates multiple possible regions, and each region proposal now consists of an object and the coordinates. In other words, we have to look at each location and consider k different block centered around that. So this was the faster RCNN. Now then, there is another model which comes called object detection model called SSD. So SSD stands for single shot detector. Like faster RCNN provides enormous speed gains over the faster RCNN, but does so in a remarkably different manner. So we are not going in much details about that, but only thing is that we have to tell that these two models which perform the region proposal and region classification in separate steps, and they use region proposal network to generate the regions of interest. Next, they are fully connected layers or positive sensitive convolutional layer to classify these regions. So SSD, that is single shot detector, does the two in a single shot, and that is why it is called a single shot detector. Simultaneously predicting the bounding box and the class it processes the image. So given an input image and the set of ground truth labels, SSD does the following: pass the image through a series of convolutional layers, yielding the several set of feature maps at different scales. Now, for each locations in each of these feature maps, the convolutional filter to evaluate a small set of default bounding box. These default bounding box are essentially equivalent to a faster RCNN anchor box, and for each box, simultaneously predict the bounding box offset and the class probability. And during the training, the match the ground truth box with the predicted box using IOU. So IOU full form is intersection over union. So let us see all these concepts in very standard model and very efficient, also called YOLO version 3. YOLO full form is you look once. So you only look once, YOLO. So it's popularly known as YOLO as one of the fastest real-time object detection algorithm. That is, the speed is measured in frames per second, FPS. So this is 45 FPS speed in which this real-time object detection takes place in YOLO as compared to RCNN, faster RCNN, etc. They are quite slow compared to the YOLO. So RCNN family of algorithm uses regions to localize the objects in the images, which means that the model is applied to multiple regions with high scoring regions of the image are considered as object detected. Instead of selecting some regions, YOLO approaches the object detection problem in a different manner. It forwards the entire image to a predicting bounding boxes and their probabilities only once through the neural network. So there are many things are now optimized here in YOLO. So let us go ahead and see some of the details about YOLO version 3, because this particular model, which we will be discussing in the computer vision model of doing this computer vision at the edge of an IoT. So YOLO first divides the image into the grid of 13 by 13, and the size of these grid cells varies depending upon the input size. And these cells, each cell is responsible for predicting the number of boxes in that particular image. So for each bounding box, the network also predicts the confidence that the bounding box actually encloses the object and probability of enclosing the objects being a particular class. So all these things are done simultaneously, that is in one go. So most of these bounding boxes are eliminated because of their confidence is low, or because they are enclosing the same objects as another bounding box with a very high confidence score, and this is called non-maximum separation. So therefore, what you can see over here is that this is an optimization of bounding boxes efficiently done in YOLO, and also this particular prediction, and that is the classification and the regression, both are done in one go. So all things are being merged together and optimized in YOLO, becoming a very fast and a very less space consuming model. So it comprises of so many convolutional layer, and then you can see that this will have this particular layer of this predictions. Now, various models which we have discussed can be compared their performance with the matrix. There are several matrix which is now we have to now understand before we go ahead. So I have already mentioned about intersection over the union for bounding the box. This is the measure which is used, or which is based on Jacob index and evaluates the overlap between the bounding box. So intersection over union is given by overlapping area between the predicted bounding box and the ground truth bounding box divided by the area of union between them. So here you can see through the example, intersection over union is the area of the overlap. So this is shown over here, divided by the area of the union. So with IO intersection of the union, you have to now decide about the overlapping area to be fixed so that the bounding box fits well with the object. The second method about performance is used, that is called precision and recall. So precision is the ability of a trained model to identify only the relevant objects, that is the percentage of the correct positive predictions, and is given by the true positives divided by the true positives and the false positive, that is called the precision. Another measure is called the recall for understanding the performance of the model, that is the trained model. So recall is the ability of a model to find all the relevant cases, that is all the ground truth bounding boxes. So it is the percentage of true positives detected among all the relevant ground truths. So recall is given by this particular formula. So recall is true positives divided by true positives plus false negatives. So here this particular false negatives means the ground truth not detected correctly, and false positives means a wrong detection, that is detected, and true positive means a correct detection. So this particular background is being built now. We have to see about the computer vision services which are available by the cloud providers, and they are called software as a service architecture. So computer vision architecture can easily be taken up by some cloud service that is running a computer vision model in the cloud. So that you can see that these particular model is provided by these different cloud providers using the cloud technology called SaaS, that is the software as a service. So most of the prominent cloud provider, they provide some sort of computer vision APIs or the services, that is Azure, Amazon, Google, and so on. They offer some variation of these kind of computer vision service, but the basic fundamentals of the models you have to now decide which can fit into these kind of services. So in that architecture, all you need to do is to have your images available, upload your images, and label them. So labeling is vital. Why? Because it is to be done with the help of domain experts and the data science. So data science is quite important. Again, even you are choosing the model or the service through the platform, that is software as a service. So once you upload your tagged image or a labeled image, that is your data set for supervised learning, then it will be applied with some machine learning model or a model which we have covered so far, and everything that is completely dependent upon now the cloud provider fully manage that particular cloud. So that is what's shown over here. First you have to prepare your data with the label, and that data is to be uploaded to the cloud. There that particular data set is presented with one of the algorithms which we have covered for doing this computer vision training, and it will train the model into the cloud, and the trained model is now available to make the predictions. So this particular model which is trained can be accessible with the help of service, that is with the REST API, and this particular model can do the predictions. So therefore, software as a service, which is being provided as a platform by different cloud providers for doing this computer vision service, is very quite similar. It depends upon the choice of the client or the developer. So there might be the fundamental difference in the UPIs and APIs which you are calling the service under the hood. So we will be going in more detail discussing about that. So let us see one such service which is called Azure Custom Vision service for doing the computer vision, that is a software as a service platform. So Azure Custom Vision is a cloud service used to deploy, build the computer vision models. This is one such example which we are now illustrating here. So computer vision uses the pretty interesting neural network technique, and sometimes it is called the transfer learning, because it uses a pre-trained model, and then you can bring your own new set of images and you can retrain the model, and that is called transfer learning. So which applies the knowledge gained out of solving one problem in a domain to a different problem which is also in a related situation. This can substantially decrease the time of creating the models from the scratch. So the features which are provided by this Azure Custom Vision service is to train the computer vision model by simply uploading and labeling the few images. That means you do not have to have a large number of images, yet you can do this computer vision fairly well using this particular technique. So you have to build an image classifier using code free and code first approach, deploy the model in the cloud, on premise or on the edge device. So this is going to be useful information for enabling the edge with AI. So here in the picture, all things are illustrated. Now you can see that this particular Azure Custom Vision application is running on the cloud as software as a service. Now over the internet, the trained model can be either deployed on the edge, and once the camera gets the new image, this particular trained model will be able to do the predictions. So Azure Custom Vision, let us see that how are you going to deploy on an IoT edge device. So you can see this inside of this Azure cloud service. So it is a custom vision service which runs inside the Azure cloud. Now for that, it will ask, it will build an image classifier based on one of the algorithms which we have covered earlier. So it will build a custom vision using custom vision and image classifier using some deep learning algorithm or a machine learning algorithm which we have discussed. So it will only provide a framework, and once the machine learning algorithm is being decided by the client or the developer, then this particular model will automatically use that and perform this computer vision. Now once this particular IoT edge module, let us see how it will be prepared. So first this image classifier is to be built, and then camera module, which now will be taking the new images, is being identified, and these together is prepared as a container, and using the Docker, it will be now deployed into the edge. So this is the edge, this is the IoT edge. So after containerization, the camera module will come over here, which is built into the cloud. Similarly, the classifier is also now deployed on the edge, and this is being enabled with the help of service which is running on the edge, that is called Azure IoT Edge Runtime, that we have already covered in the previous lecture. Once these models, that is for the image classifier and the camera capture, is in place, and this image camera capture and the image classifier, they communicate with the help of a protocol called HTTP. So HTTP is very close, tight net protocol. They have to work very closely. Now this particular deployment will enable the edge to do the insight. So this particular, for doing more detailed insight, that particular pre-processed information or data or insights, whatever is being inferenced by IoT edge, will be sent back to the IoT hub, that is into the Azure cloud. So send the results of an image classifier to IoT hub for making the business decisions. So the topic is to create an image recognition software or a solution with an IoT edge and Azure services. So you can see that a lot of applications uses this image recognition, and maybe that this particular application, such application needs a solution that is a vision-based solution, such as scanning the fruits for quality, for segregating into the or classifying into the quality with a medium quality, low quality, or high quality, and vegetables. And also there are various scanning at the airport for different baggages, self-service checkout. There are many more applications. So let us see how that is all can be done with the help of this IoT edge IoT. So in this particular lab session or lecture, some of the components, some of the hardware which is needed is that Raspberry Pi 3B or better, and an USB camera and a speaker. So this is the picture of Raspberry Pi board. So Raspberry Pi board is a standalone computer, and it has enough of processing power, and the device has a limited memory within it. So Raspberry Pi 3B Plus board has 1 GB of RAM, and now a newer version, that is Raspberry Pi 4, has come. Now this particular board will be used to prepare to make this edge, IoT edge. it will work as an IoT edge. And other thing which you require is a desktop with a Ubuntu installed in it. Then you will be needing, since it's a image recognition solution, so you'll be requiring a USB camera, and that USB camera, that is an IoT camera which is connected to a USB port here into this Raspberry Pi, and this camera is a device, or it is a thing. Now it is this particular IoT. This will become an IoT edge. This is internet connected, and this will be now in turn will be connected to the cloud. Will have the connectivity to the can be established. Now there are two more icons which are shown. You require a Ubuntu machine or Linux based machine, and then another thing is you have to need a Docker. So all this is a requirement for this particular exercise. So let's see that once you have a Raspberry Pi board, then you have to install the Raspberry Pi operating system, and for that you have to now do many things like installation. So the installation of a Raspberry Pi operating system called Raspbian has to happen to run that particular board. Then on the cloud side, you have to create an Azure services. So that is called an Azure IoT Hub on the cloud platform that is offered as a software as a service. So this Azure IoT Hub, you have to create your details for that devices. For example, you have an IoT camera and Raspberry Pi. So these devices need to be registered here in Azure IoT Hub runtime. So once it is done, then you have to install on the Raspberry Pi Azure IoT Edge runtime on Raspberry Pi. So you have to download the configurations that is being described, and then you have to deploy. Now, then again, you have to install the command line interface Azure CLI so that it may accept CLI commands from the console, and then you have to deploy this IoT edge to the device. So you can see from once it is being prepared, this IoT at the IoT hub, it will be containerized, and that particular services are now deployed on IoT edge device. So this particular deployment of an IoT edge runtime from the Azure IoT hub is done through a technology which is called the Docker. So that is what we have already mentioned. So let us see that once these requirements are done, then let us see the solution, how it look like. So that solution will scale from Raspberry Pi to the desktop. So let us see that this is an IoT camera, and here you have the Raspberry Pi board which is running an Azure IoT hub runtime on the board, and so this is an environment which will become like an IoT edge. So this particular IoT edge now will be installed with the using the Docker, the trained machine learning model, and this particular camera will take the picture of a fruit, and it will be able to detect and display that this is the fruits. So let us see that now again, come back to our point to understand more about these setup details. So we have to create the classification model using the Azure Custom Vision, and Azure Custom Vision service is simple to create an image classification machine learning model without having to be the data scientist or a machine learning expert. So what you have to do now, you have to become like a data scientist. You have to prepare and upload the labeled images here in the Azure Custom Vision service, and then you can train your model. And once the training is done, then you have to evaluate the model whether the model is properly trained to do the correct predictions or not. So this particular classifier may be further be improved by adding more data set or more samples. So let us see that how you are going to create this particular model. So you have to create the custom vision service, and then you have to gather the initial data or the images, and then you have to upload and train your model. And here there is a train button. Once you train the button, then the model will be trained. And once the training is done, then it will show the performance metric of the trained model. So the precision is 97.4 and the recall is 93.3. Both are fairly good. Now let us see that computer vision prediction thresholds you can set. So here this is the example that if your model is not having the accuracy and the precision as per your need, then you can adjust. You can train the model by modifying this threshold. Let's understand about that. So custom vision offer the fluent prediction threshold adjustment to improve the model performance. So in this case, we prefer the higher recall over the higher precision. This is important not to lower those threshold too much, as the model performance will suffer significantly. And having the low probability threshold will increase the number of false positives. So the model is supposed to be deployed in a production settings. We can't stop the production line for every false positive detection by the model. Therefore, the key performance indicators or index KPIs will be as follows and will be tunable to improve the model performance. So the main matrix to optimize is the MAP. So this particular average of all that precision and recall is MAP metric. So this particular metric cannot be lower than 85%. Let us say that if we optimize the mean metric. So this means that recall and precision are also equally important, and they should stay above 80%. If that is to be enforced in this particular threshold, then your model will be giving a good accuracy, and this is what is shown over here. So once these models are trained up to the satisfying performance using these KPIs, then this particular classification model classifier is now ready, and you can now deploy with the help of Docker. So you have to now containerize this trained model on the cloud and then deploy it on this particular edge. So that is what is the next step. So once it is containerized, then you have to download, and it will be shipped or deployed to the IoT edge, which is nothing but the Raspberry Pi board, which is being built or registered with the Azure IoT Hub. So this is some of the more detail that you have to now build the solution, and you have to deploy using Docker and container. You have to push it on the IoT hub or an edge IoT edge, and then you can also monitor its functionality of that IoT edge. So that was a brief of the discussion on the practical side also. So let us summarize this lecture. What we have understood in this lecture, we have understood about the computer vision fundamentals. That computer vision needs some of the machine learning models. They are called image classifier to build the image classifier. So different machine learning algorithm or the models which we have discussed is RCNN based models and YOLO based models. Then we have seen about the Azure computer vision service, that is the software as a service. We have also told that all other services provided by different cloud vendors are similar in nature. So this particular use case taking from Azure is good enough to understand the functionality of every other solution provided by different vendors such as Amazon and Google. We have also covered the use case and the practical lab session here in this particular lecture. Thank you. Myself, Dr. Rajiv Mishra from IIT Patna. The topic of this lecture is Introduction to Docker Container and Kubernetes. In this lecture, you will be knowing the following information. First, we will introduce to the Kubernetes. For that, we will require the background of container orchestration. We will also make you understand the concepts of Dockers, and we will show you that due to the Kubernetes, you will be able to deploy and manage the softwares on the IoT edge. So before I go ahead, let us set some motivation why we need to discuss Docker, container, and Kubernetes, three different technologies. So you know that IoT edge, to build the edge, you require this kind of technology, which is called a Docker container. So this Docker and container will allow the edge to run the functionality or capabilities of a cloud like, that is, it may mimic the functionalities of the cloud at the edge. So the enabling technology is Docker and container. Now to manage so many number of Docker and containers which are running over so many IoT devices, therefore manually it is not possible. Therefore it requires an automation for this, and therefore there is a need for container orchestration tool, which is Kubernetes. So Kubernetes in turn is used for the production. For example, if you're running a smart city application using IoT, then you require this kind of services also to run. So with this motivation, let us go ahead and discuss about the Kubernetes. So Kubernetes is a Greek word for a captain of a ship. So Kubernetes is also known as K8s. So K8s. So if you see the Kubernetes, so if you count the number of letters, they are 8 in number. So K and S is retained, and in between there are 8 letters. So it is also known as K8s. So this Kubernetes was built by Google, and later on it was open sourced. This Kubernetes Google made for container orchestration or to use the containers in the production. So this open source project, which is Kubernetes, is one of the best and the most popular container orchestration technologies out there. The applications grow in size, therefore it spans over multiple containers which are deployed over multiple servers. Therefore, their orchestration or a lifetime management of these containers becomes a complex task manually to do it. To manage this complexity, and automation with the help of Kubernetes, which is an open source API, controls how and where these containers will run. Now to understand this Kubernetes, we have to understand two concepts. One is about the container and the other is called orchestration. Now before we go ahead, I will now let you aware about the use in the IoT. So in the IoT parlance, this Kubernetes is, for example, you have this kind of situation where you have an IoT device and so many IoT devices are now running. And these IoT devices are having connectivity with the things, that is the sensors and actuators. Now to manage this particular IoT devices are also sometimes edge enabled. So this IoT edge now is running the container or containerized applications. Now these containers, to manage the lifetime of a container, you require a service which is called a Kubernetes service, and Kubernetes in turn will manage these containers, so that if, let us say, that server or let us say some container is having an issue at a particular hardware, so the Kubernetes will automatically overcome from those kind of things. So we will see all those details. So introduction to Kubernetes, let us introduce two concepts to understand the background for Kubernetes. So the containers is an isolated environment to have their own process services networking interface for an application that mounts similar to the virtual machine, except the fact that they all share the same operating system kernel. Meaning to say that if you contrast with the virtual machine, so in the virtual machine, an application to run, it will be packed with the binaries and all dependencies which application needs to run, and the operating system on which this application is running. And this particular entire suite, which comprises of the guest operating system, the binaries and libraries which is required to run the application, this is called virtual machine. Now virtual machine is supported to run on an hypervisor. Now this entire scenario is now changed with the introduction of new technologies, that is called containers. Now containers do not carry the guest operating system along with the application. Therefore, you can see that in the container, it is only the application and the related binaries. So therefore, this container is a lightweight and can be packed in many numbers compared to the virtual machines. Now, there is a container engine, which is also popularly known as the Docker, and this Docker supports running of these different containers. And the operating system becomes a common entity for the container or a Docker engine to run. So therefore, container is free from carrying the operating system, and operating system becomes a common entity. So this is a more efficient system or environment to run the application. Now coming to orchestration. So orchestration is a set of tools and scripts that can help the containers in a production environment. So an orchestration consists of multiple container hosts that hosts containers, and if one of these applications is still accessible through others if some containers are failed. So that is what is the functionality of orchestration. And Kubernetes is one of the orchestrator tool that is an open source developed by the Google that we will discuss at a later point of time in this further slides. So the Kubernetes consists of one computer that gets designated as a control plane. When we say computer, may not be the physical computer, it may be the virtual machine as well. So this particular Kubernetes has a designated system, and that is called a control plane. Now each of these has the complex but robust stack, making this orchestration possible. So Kubernetes orchestrates cluster of virtual machines. So you can see here, this is the cluster of virtual machines which is running these kind of worker nodes and schedules the container to run on those virtual machines based on their available compute resources and the resource requirement of each container. So the Kubernetes automatically manages the service directory, incorporates load balancing, tracks resource allocation, scales based on the compute utilization. It also checks the health of the individual resources, enables the application to self-heal automatically, restarting or replicating the containers. You can get familiar with these Kubernetes components, that is the control plane component. So this is the control plane component. The other one is called the worker nodes. Now let us go inside this details of this control plane components, and then we will see the worker nodes component, which will bring up this complete details of Kubernetes on the platform. So Kubernetes control plane components comprises of etcd. So etcd, that is etc daemon, also is a fast, distributed and consistent key value store used as the backing store for persistently storing Kubernetes object data such as pods, replication controllers, secrets, and services. Therefore, this etcd is a database of all the states information of the worker nodes. That is the Kubernetes cluster. So etcd is the only place where the Kubernetes stores the cluster state and metadata. So this is one of the most important component of a Kubernetes which runs in the control plane. The only component that talks to the etcd directly is the Kubernetes API server. So all of the components read and write data to the etcd indirectly through API server. So they have to now connect to the API server, and through that they can access this etcd. So etcd is also implements a watch feature which provides an event-based interface for asynchronously monitoring changes to the keys. Once there is a change in the key, its watchers get notified. So the API server component heavily relies on this notified and moves to the current state of etcd towards the desired state. So the state of this entire Kubernetes cluster is maintained at etcd, and to access this etcd or to modify, that is done through API server. The other component of a control plane is API server. API server is the only component in the Kubernetes that directly interacts with etcd that we have already seen in the previous slide. So the API server has the following functions. The first one is it provides a consistent way of storing the objects in etcd. It performs the validation of these objects so the client can't improperly configure the objects. It provides the RESTful API to create, update, or modify or delete the resources. So these are the functionalities. It performs authentication and authorization of requests that client sends. And it is also responsible for the admission control if a request is to try, create, modify, or delete a resource. Now we will look to the controller manager. That is the third component of the control plane. So in Kubernetes, controllers are the control loop that watch the state of your cluster and then make the request changes wherever it is needed. Each controller tries to move the current cluster state closer to the desired state. So controller tracks at least one Kubernetes resource type, and these objects have a specific field. So controller types are mentioned over here. That is the node controller, service controller, endpoint, namespace controller, deployment, and stateful set controller. Now comes finally the last component in the control plane called scheduler. So scheduler is the control plane process that assigns pods to the nodes. So when we say node, we mean that the worker node, and this becomes the cluster, Kubernetes cluster, part of the Kubernetes cluster. So the unit of assignment is called the pods, and the pods contains the cluster. So therefore, the scheduler is a process that assigns pods to the nodes. So which pods are running in these nodes? That is the job of the scheduler. So scheduler is very important. It now creates the pods, which is the unit of execution. So for every pod the scheduler discovers, the scheduler becomes responsible for finding the best node for that pod to run on, depending upon what are the resource requirement for the pod and where that resource is available in which of the nodes. So that particular mapping is done by the scheduler, because the scheduler knows the current state of all the nodes, and when a pod is requesting to be assigned a particular node, then the scheduler does that. So once it finds a feasible node, it runs a set of functions to score the nodes, and the nodes with the highest score get selected. This is the method which scheduler uses. Finally, now we will be looking up the worker node components. So in the worker node, if you see, there is a component which is called a kubelet. So kubelet is an agent that runs in each node. You can see that here there is an example of 2 nodes in every node. This kubelet is running as an agent responsible for everything running on the worker node. So kubelet controls the entire functionality of the worker node. It ensures that the containers run in a pod. The main functions of the kubelet services are register the nodes it's running on by creating the node resource in the API server. So it interacts with the API server. To do this, continuously monitor the API server for the pods that got scheduled, start the pods containers by using the configured container runtime, continuously monitor the containers and report their status events and resource consumption to the API server. So you can see that the API server used to update the state in the etcd. For that, the kubelet has to keep on continuously informing the API server about its current state in the worker node. Then comes the kube proxy. The kube proxy also runs as a service in every node, worker node. So the kube proxy runs on each node and ensures that one pod can talk to another pod, and one node can talk to another node, and one container can talk to another container. So that means kube proxy becomes a point of interaction or communication, just like you can think of a proxy server working in the internet for internet connectivity. So this kube proxy is responsible for watching the API server for changes on the services and the pod definition to maintain the entire network configuration up to date. So this kube proxy is the mechanism by which all the nodes, all the containers, they are properly networked and they will be able to communicate with each other. Similarly, now there is a thing which is called a container runtime. So container runtime is also a worker node component. So it has 2 categories of container runtime. One is that lower level container runtime focuses on running containers and setting up the namespace. A high level container runtime focus on formats, unpacking, management, and sharing of the images. So container runtime has to take care of pull the required container image from an image registry if it is not available locally, prepare a container mount point, and alerts the container to assign some resources, and pass system call to the kernel to start the container. So therefore, container runtime is almost like an operating system of a worker node, which is now supporting these containers and the pods. Now let us introduce about the Dockers. So the most popular container technology is called the Docker container. So Docker is an open platform for developing, shipping, and running applications. So Docker enables you to separate your application from your infrastructure so that you can deliver the software quickly. Now there are 2 important things in most of the cases. There is a software and there is an infrastructure and the hardware. Normally, to make this management easy, that is the management of infrastructure to be separated out of the software, this particular separation is done with this help of this particular technology. So with Docker, you can manage your infrastructure in the same way as you manage your applications. So by taking the advantage of the Docker's methodology for shipping, testing, and deploying the code, you can significantly reduce the delay between the writing of code and running on the production. So Docker provides the ability to package and run the application in a loosely isolated environment, which is called the container. So let me explain you in more detail before I go ahead the use of Docker. Now you know that the applications are containerized. What do you mean by these applications are containerized? Now when you write an application and the developer develops on a particular computer, that application has to run on different kind of environment and systems. Therefore, the lifetime of the application where it runs is not very clear at the time of development. To make that application independent of the system or the dependencies, therefore this application, to make this independent of a system, so application has to be or need to be containerized, and the environment is to be infrastructure free. So Docker is the technology which gives these applications make independent of the platform dependent. So the applications are containerized. Containerized means that all the dependencies of the application, such as the libraries and binaries, they are packed together and they are called containers. As far as the operating system is concerned, if let us say the application is tied up with the operating system, then without that operating system, again the application will not be running it. So to make it independent, the container that does not contain the operating system, it is out of that. Now this hardware and all the operating system dependencies, to make it independent, the Docker engine comes into the play. Once you install the Docker engine, then it will be the point where these containers will be running their applications. So therefore, in an IoT application, IoT nodes or edge nodes, that is also called an IoT edge, will run these containers or a Docker container. So that means first Docker will be running on this IoT edge hardware, and on top of it, the containers will be placed and they will be running. Now, if the machine learning you want to run on IoT edge, then the machine learning models need to be containerized, and once it is containerized, then they can run as it will be placed and they will be running. Now, if the machine learning you want to models need to be containerized, and once it is containerized, then they can run as a container onto that IoT edge. So therefore, we are now discussing. We have already told you about the container. Now Docker, we are telling that to run the container, you require the Docker engine. The Docker engine is nothing but a kind of operating system for the containers. So let us see the architecture of the Docker. So Docker uses a client server architecture. So there is a Docker client. So Docker client talks to the Docker daemon. So here there is a Docker daemon and here there is a Docker client. Why the Docker client talks to the Docker daemon, which does the heavy lifting of the building, running, and distributing your Docker containers. So Docker client and the Docker daemon can run on the same system, and you can connect a Docker client to a Docker daemon. So Docker client and Docker daemon communicates with the help of REST API over the Unix socket or on some network interface. So this endpoint is explained over here as either the REST API over the Unix socket or network interface. Now another Docker client is the Docker Compose. So and that lets you work in the application consisting of the set of containers. So Docker daemon then listens to the Docker API requests and manages the Docker objects such as the images, containers, network, and volume. So the Docker daemon can also communicate with other daemons to manage the Docker services. So the Docker client is the primary way that the Docker users interact with the Docker, and when you give a command such as Docker run, then the client sends these commands to the Docker daemon where it carries them out. So when you say Docker run at the Docker client, then this particular command will be now picked up by Docker daemon and it will start the execution or with one or more Docker daemon. So Docker registry is also a component. It stores the Docker images. So Docker Hub is a public registry that anyone can use it. So Docker is configured to look for the images on the Docker Hub by default, and you can even run your own private registry. So let's see about the Docker objects. So Docker objects. So when you use the Docker, you are creating and using the images, containers, networks, volume, plugins, and other objects. So these particular images is completely packed up all the dependencies of an application, and the application and also often includes the containers, networks, volumes, plugin, and other objects. So Docker desktop includes the Docker daemon, the Docker client, Docker Compose, Docker Trust, Kubernetes, and other more things. Now let us see that how Kubernetes you can use to deploy the software on the edge devices. So this also is applicable for an IoT edge. So the architecture shows the flow from the cloud to a virtual kubelet. So here you can see this particular illustration, the workflow from the cloud to the virtual kubelets, through the edge provider down to your edge devices. So this entire thing is explained here, the workflow. So here you have to see that there is a operator, and you have to this operator specifies for the pod, and then this particular pod specification will map to the Kubernetes master, and the Kubernetes master in turn will find out a virtual machine on the Kubernetes nodes. So this, that scheduler does this kind of mapping, and then IoT edge is called a virtual node. If let us say there you want to install the IoT Azure IoT edge services, so it requires that particular device to be first virtualized and run a virtual machine on top of it. That particular node becomes the virtual node where this IoT edge connector will run, and then IoT edge deployment will happen with the help of IoT hub. And this particular deployment on-premise edge devices will be running these IoT edge, and this Kubernetes master will manage it. Now, these Kubernetes nodes will run the pods in the nodes that we have seen in the previous diagram. So that pod is called a Kubernetes pod. Kubernetes pod will have the virtual kubelet, and this virtual kubelet in turn will manage that pod inside that Kubernetes. And IoT edge provider will be now using this orchestrator called Kubernetes master. So first, the virtual kubelet project lets you create the virtual node in your Kubernetes cluster, and that Kubernetes cluster consists of these kind of things, or this is the nodes which are running as IoT nodes. A virtual node is like the virtual machine, like most other nodes in the Kubernetes cluster. Instead of it is an abstraction of a Kubernetes node that is being provided by virtual kubelet. So it is an IoT hub. It can schedule the workloads to it and treat it like any other Kubernetes node. So when a workload are scheduled to this virtual node, edge provider comes in. That's depicted over here. So the edge connector or the edge provider, which are working in tandem with the virtual kubelet, it takes the workload specification that comes in from the Kubernetes and converts it into an IoT edge deployment. Then this IoT edge deployment is shipped back to the backing of IoT hub for its virtual node. Lastly, the IoT hub in turn pushes this deployment down to the target devices. So therefore, what we have seen over here is the entire ecosystem of using the Kubernetes to orchestrate as the orchestrator for managing the Azure IoT hub clusters. That is nothing but the IoT devices which are running these Kubernetes pods. And inside pod, that containers are running, and containers is nothing but containerized application which runs on the IoT edge device. So with this, let us summarize the lecture. So what we have seen is the use of Kubernetes very much in the context of IoT. So you know that Kubernetes is an orchestrator, orchestration engine. Why this is needed is because so many IoT devices are running their software with the help of containers, and this container orchestration, that is the lifetime of a container, requires continuous monitoring states of these containers which are running inside a pod of a Kubernetes cluster, requires automation like Kubernetes. So we have already discussed about the container. So container is a process with the help of Docker and containers. We have seen that this particular application, to make it platform independent and run on any of these IoT devices, we require the concept of a Docker and container. And Kubernetes is automatic management, that is at the production time. So power of the Kubernetes we have seen is to deploy the software on IoT edge devices. So with this, I conclude this lecture. Thank you very much. IIT Patna. The topic of today's lecture is ML-based predictive maintenance at the IoT edge. In this lecture, we are going to cover the following details listed over here as overview. So in this overview, we will now briefly talk about the machine learning and IoT, how they goes together. Then the prime objective of this lecture is to introduce the processing of an IoT sensor data with the machine learning, and that is specifically at the edge. While we touch many aspects of machine learning workflow in this lecture, but this lecture is not intended as an in-depth understanding or introduction to the machine learning. So we do not attempt to create highly optimized model for the use cases we use here in our lecture. So it is just an illustration to represent how the machine learning is used for creating the predictive maintenance process for IoT and at IoT edge. That is the process of creating and using the viable model from machine learning for IoT data processing. So let's get started with looking at the machine learning development at an IoT edge workflow. So that starts with the data collection. So the sensors used to send the data of that particular environment which they are embedded into. That is, they will collect a time series data which is coming from various sources and formats and the rate. So this is an example where these sensors are embedded into the things. So these sensor will collect the sensor data. Sensor data is collected, and this particular data is in a particular form, and that is called the time series data, which is coming from different sources, that is from different sensor sources, and often having a different formats and the different rate in which these sensors are sending the data. So this is called the collection, and this collection has to now communicate through the telemetry or through data ingestion mechanism to the process, and this particular process may run either at the IoT, either at the edge, IoT edge, or at the cloud. The next stage after this processing is doing the pre-processing of this incoming data, and that is to parse, normalize, enrich, and transform. So this particular process is a pre-processing of this sensor data, which is also or a time series data, the time series data. Yeah. So sensor or a time series data which sensors used to send will put under the pre-processing stage, that is called the process here, which is shown over here using various tools and techniques which are available at the cloud. The next stage after this pre-processing is the storage. So this particular storage will be either in the cloud or at the edge to a little size. So the cloud has enormous level of storage, and it uses various multi-layered time series data store, which is optimized for variety of analysis. So there are many possible data stores which are being offered as a service by different cloud providers, and the application developer has to choose one of these particular platform. So once the data is stored, then this particular data will then be explored and put on the monitoring of these things. First of all, second is it may perform an operational analysis. That means using the dashboard, you can see the progress, how the machine is working. Third is using this particular data, which is often put in the store, create the model using the machine learning algorithm, and this is called the learning phase. This particular learning model, when they are deployed with and when they will see the new data incoming from the sensor, they will be able to do the prediction. So this is done in the analysis phase. So analysis is just to run an ad hoc queries for monitoring the environment, or operationalize using asset-based analysis, or use the machine learning algorithm to train the model, and this trained model often put or deployed in the cloud or at the edge. to make the predictions. And these particular predictions are often used to make this business intelligence or the business logic. For business intelligence or business logic. Now let us go ahead with discussing a little background of the machine learning. Nevertheless, we are not going to discuss everything about the machine learning, only a little background which is good enough to understand this particular topic. So the machine learning with IoT reference we will talk about. So starting with some little definitions. So as you see that this broad area is often called as artificial intelligence. Artificial intelligence is defined as the property of a machines that mimic the human intelligence behavior as characterized by the cognitive ability, memory, learning, and decision making. So that means artificial intelligence will make this computer or the machine mimic the intelligence like human intelligence and will be specialized in the topics like learning, forecasting, predictions, decision making, and other cognitive ability. So therefore, we can understand this artificial intelligence is a program that can sense, reason, act, and adopt, and very well often used in the IoT parlance. Now, this particular artificial intelligence is supported by the machine learning. So machine learning is a branch of artificial intelligence and computer science which focuses on the use of the data. So here we will refer to the IoT data. So focuses on the use of data and the machine learning algorithm to imitate the way humans learn through the examples and gradually improves the accuracy of learning for making the predictions. So therefore, the machine learning algorithms whose performance improves as they are exposed to more data over the time. So this particular aspect, since these IoT sensors are generating a lot of data as the time goes on, more data comes into, therefore it is a good opportunity to train the machine learning model with a good accuracy at all times. Now the next part, that is the deep learning. So deep learning uses the labeled data set, also known as supervised learning, is to inform its algorithm, but it doesn't necessarily require the labeled data set sometimes. So deep learning can ingest unstructured data in its raw form, and it automatically determines the set of features which distinguish different categories of the data from one another. That is called classification. So the deep in the deep learning number of layers in the neural network. So non-deep machine learning is more dependent on human intervention, and human experts determine the set of features to understand the differences between the data inputs. So the deep learning is a subset of a machine learning in which multi-layered neural network learn from vast amount of data. So as you know that the humans also uses neurons and neural networks. Here in deep learning, it uses artificial neural networks for learning. So once it sees the data, it learns through these artificial neural network. So as we collect a vast amount of data, therefore learning this model will bring more accuracy or to the predictions. Now let us see the use of machine learning for predictive maintenance. So predictive maintenance, using simple machine learning algorithm, we can create a simple model of a machine with a normal operating conditions for any application and determine the values that falls outside that normal area. So for example, if you can train a model for a motor which is capturing the vibration with two sensors, namely A and B, in the normal working conditions, that means that using normal data points, the machine has a good understanding what the motor vibration value could be approximately when the motor is operating in a normal mode. Normal mode falls into this particular area. Now let us say one day at a random point in the time, the model observes that the value of sensor A is 8 here. That means it is away from the normal. And the value of the sensor B is still 2. So you can see that this particular value of a sensor B is 2, whereas for sensor A, this value becomes 8. So this particular point, which is drawn over here, is not the normal operation. So this is clearly an unusual value. So the trained model can easily say that this new value is not normal, and this is called an anomaly detection. Often it is very easy to do this anomaly detection with the help of machine learning, and this is also one of the way you can do this predictive maintenance, or you can predict when this abnormal behavior will be now coming and showing into that particular operation of the motor. So this is how the machine learning works to detect an unusual behavior of a machine. So let us go ahead and talking about more details about the predictive maintenance. So predictive maintenance has now completed its journey, starting with the reactive maintenance. So let us introduce the predictive maintenance with the full pipeline, with the full growth to this stage, which is called the predictive maintenance stage, which is the most advanced predictive maintenance for industry 4.0. So in the past, the companies used the reactive maintenance. So reactive maintenance, when the equipment is down, this is focusing on preparing the assets once the failures have occurred. Now then, this will stop functioning of the machine in the factory environment in the reactive maintenance. Then they thought of improving this downtime and using the preventive maintenance. Preventive maintenance is also called the schedule-based or a planned maintenance. So schedule-based or a planned maintenance refers to performing the periodic maintenance based on the manufacturer's recommendation, and the focus was on reducing the failures by replacing the parts based on the worst case lifetime for critical pieces of manufacturing tooling. So this preventive maintenance is better than reactive in terms of improving the downtime of the machine, but still it is not sufficient to reduce the downtime to a zero. Now then comes the condition-based monitoring or maintenance. So here manually inspect with preventive maintenance and replace the parts when showing the sign of the failure. Now with this explosion of computers and sensors, now these companies and IoT, these companies or the industries or manufacturing companies are now engaged in machine learning led the condition-based maintenance to reduce this cost while improving the uptime of this particular factory. And there comes the predictive maintenance. So predictive maintenance takes the condition-based maintenance to a further level And in this methodology, machine learning analytics is used to predict the machine's failure early by examining the real-time sensor data and detecting the changes in the machine health status. So it often uses the sensor data, which is nothing but a time series data, and will predict when the machine is going to fail. So that is why this is called the predictive maintenance. It will do the analytics to find out or to predict the failures of the machine, and therefore before it fails, the maintenance is done, and therefore there is a very little downtime. And now the companies are improving with the technologies like IoT. So let us introduce this predictive maintenance in more details. So predictive maintenance employs the advanced analytics on the machine data, which is collected from the end sensor nodes to draw the meaningful insights and more accurate predict the machine failures beforehand. It comprises of three steps. One is to sense, the second is to do the computation, and third is to perform and act. Sense, compute, and act. Let us understand these three different things in more details. So here, the data from the sensors, like here, the sensors are embedded into the things. So we are talking about IoT. That is, the sensors embedded in the things, and thus they become the data source. So these particular sensors will generate the data. So depending upon the machine types and required the failure analysis, different sensors are used. So different sensor signals such as the temperature sensor or a sound, magnetic field, current, voltage, ultrasonic, vibration, these sensor data are now analyzed to predict the failures. So you can see here, these sensors often send the data, and then these are often used to do this computation and predict the time to fail. So the predicted information from the sensor data analysis is used to generate an event, work order, and notification. So the sensor data is also used to visualize the machine's overall operating conditions. So that is an action. So action is taken when the event reports an anomaly, a machine that is nearing the end of its useful life, or when wear and tear is detected in the machine part. Therefore, what we have told you here about the introduction of a preventive maintenance is that the sensors will monitor the machine's its parameters such as temperature, sound, magnetic field, current, voltage, ultrasonic, vibrations, etc., and send this particular data for performing the computations. So this particular sensor data is often used to visualize the machine's overall operating conditions. So the action is taken when the event reports an anomaly, a machine is then nearing the end of its useful life. Predictive maintenance problems. So let us see what are the issues which are addressed in the predictive maintenance. Will this equipment fail in a given period of time? What is the remaining useful life or time of failure of a machine? How to quantify the wear and tear of expendable components? So this is a subset of remaining useful life and focuses on the shorter living subsystems. For detecting anomalies in equipment behavior,
मिला के सीट तो है, खाली नहीं है। सीट खाली है, आ जाए, यहीं पे आ जाए।
with further analysis, it can improve the failure classification and also optimize the equipment setting. So let us see the machine learning workflow in the predictive maintenance. There are 6 steps. Is we have already some of them we have told. The first is to define. Is that clearly define the problem and intended goals? Then you decide how to tackle this particular problem. Second step is to prepare. The essential thing here in the predictive maintenance under preparation is to prepare and clean your data. That is pre-processing. Depending upon the time series, the observations may be a daily, weekly, monthly, quarterly, or yearly, which require to be classified and prepared in this time series data. Third is to analyze. That is, now your data has been prepared, you can start doing the analysis. Time series data can be decomposed into the several components, including the trend and seasonality. Fourth is the model. So model is to predict using the insight from the analysis. So therefore, the step 4 of this generating or training the model is to combine the trend and seasonality to create a forecast. Refine the weightings of each component to produce an accurate model. If needed, edit the forecast to account for any special factors like sale and so on. Fifth factor is about deploy. So once you have a good model, it's the time to deploy it and make the forecast live. This may take the form of a performance dashboard, a report, or a web. Now, finally, the stage of the preventive predictive maintenance is called monitor. So once the forecast is live, make sure that monitor its performance. This might involve updating the forecast as the new data comes and available and calculates its accuracy. For example, MAPE, that is mean absolute percentage error. So with this, let us go ahead talking about the machine learning workflow, and we will see about the different aspects. So as we have already stated that in the machine learning workflow, the important or the first step is to clearly define the problem. What are you going to solve with the help of machine learning prediction models? So this will create the predictive and the intended goals and the outcomes. After that, you can decide how to tackle the task at hand, and then you can use the different tools for data preparation, and then use this for analysis and modeling for the deployment purpose. Now, in the prepare stage, that is the data preparation or a pre-processing the data, it is essentially to properly prepare and clean the data that will be used to train the model. With good accuracy, and then use it for making the predictions. So this is very essential step of cleaning or preparing the data set, so that the machine learning model can be trained with a good accuracy and it will be put for its predictions. The next step is here into the data preparation is to data cleansing. Might involve removing some of the duplicate or noise or inaccurate and dealing with the missing data or sometimes the outlier data to make this data making it work with training the model accurately. So in case of predictive maintenance, the data will be in the form of a time series data. So all this preparation has to happen with the time series data. Now, depending upon what is being predicted, the observations might be categorized into daily, weekly, monthly, quarterly, and yearly intervals. Now, machine learning workflow in the analysis part, once the data has been prepared, the next is to analyze. Now, here for time series data, this involves decomposing the series into the constituent part, and they include the trend and seasonal effects. So, trend is a long-term overall pattern of the data and is not necessarily linear. Seasonality is a recurring pattern of a fixed length, which is caused by seasonal factors. So, these two things are very important in the analysis. Modeling or the training the machine learning model is called modeling. Now, to make the predictions, when the model is created by combining trend and seasonality components, you are having various softwares, and these particular softwares will now manually refine the models to have this more accurate model. So, different performance metrics we will see about that, how to judge the accuracy of the model. So, models can be edited to account for any special factors. However, careful introducing the biases into the predictions make it less accurate. So, we have to now be careful while deciding about the model. Now, the next stage is called deploy the machine learning. Once the model is working right and acceptable accuracy, then it can be deployed and make it live for making the predictions in the real time. This means that the decision makers with the business logic can utilize and benefit out of these particular predictions. Sometimes a visualization may also be helpful, and it will be done through the performance dashboards or graphic or a table or a report or a web application. So you may also include the prediction intervals as we have stated in the previous slide, and expected this particular limits is expected in the future values to fall within between if the model is correct. So monitor is the next step in the machine learning models. Once the prediction goes live, it is important to monitor its performance, and therefore various accuracies and error mechanisms are there to monitor the model performance. So the popular measures are mean absolute percentage error and the mean absolute deviation. We are going to look into these aspects more clearly. So data scientists, they are specializing in this kind of technology. So using error, they will be able to monitor the performance of the model. So therefore, machine learning methods for predictive maintenance, from the machine learning point of view, they are going to solve two different problems. One is called classification, the other is called regression problem to solve this predictive maintenance. So classification means will it fail or not? So it will classify into two classes. Sometimes multi-class classification, also will it fail for a particular region X? This is all classification where yes or no or multiple classes are there. That is called a classification in the predictive maintenance. Regression aspects or a regression problem in the predictive maintenance is about after how long that machine or the failure will happen. So this will be a predicted value, not a class. So classification has to predict about the class, where the regression has to predict about a value. Now, to do this classification and regression related problems in predictive maintenance, you require different traditional machine learning approaches, such as decision tree, random forest, gradient boosting, trees, isolated forest, support vector machines are some of the traditional machine learning algorithms. Similarly, for deep learning, different approaches are there. That is called convolutional neural network (CNN) or multi-layer perceptrons (MLPs), recurrent neural networks, and LSTM, long short-term memory, and GRUs, that is gated recurrent unit. Now, there are hybrid of deep learning and a physics-based modeling. So you can use the physics-based modeling to generate the training data set where the data is lacking. Similarly, you can also physics-based modeling to reduce the problem space. That is, you can use for feature engineering. You can use physics-based modeling to inform and validate different deep learning models and so on. So we have now covered the entire predictive maintenance from the machine learning aspect. So let us go ahead and understanding so-called deep learning methods, which is very much needed in the predictive maintenance. So deep learning has proven to show superior performance in certain domains such as object recognition and image classification. Nevertheless, using time series data also, it has shown a very improved models and often very popular in the time series data analysis also. Now, predictive maintenance is also a domain where data is collected over the time to monitor the state of the assets with the goal of finding pattern to predict the failures. For this, you know that the deep learning algorithms are very powerful and capable to function this kind of problems in the predictive maintenance. So for among the deep learning, the popular models to do this time series predictions are long short-term memory, that is LSTM networks, or the deep learning models, which especially appeal to the predictive maintenance due to the fact they are very good in learning from the sequences, and time series data is nothing but a sequence of data over the time. So this fact lends itself to their application using the time series data by making it possible to look back for a longer period of time to detect the failures. So therefore, this LSTM allows you to monitor over a longer period of time to detect the failure patterns and therefore by detecting the anomalies over the period of observations. Now, the deep learning method, another is called multi-layer perceptrons. So there the neural networks like multi-layer perceptrons provide the capabilities which are offered by the few algorithms such as robust to the noise, non-linear, multivariate inputs, multi-step forecast. Now, the next model in the deep learning is called convolutional neural networks, CNNs, or a type of neural networks. They are designed efficiently to handle the image data. The ability of CNN to learn automatically extract the feature from the raw input data that is in the form of images can be applied to the time series forecasting problems as well. So that means a series of observation can be treated as one-dimensional image that CNN model can read and distill the most salient elements. So the feature learning is an automatic identification, extraction, distillation of salient features from the raw input data that pertain directly to the prediction problems that is being modeled. So CNN gets benefit out of multi-layer perceptrons for the time series forecasting, namely the support for multivariate input, multivariate output, and learning arbitrary but complex function relations that do not require the model to learn directly from the lag observations. The model can learn the representation from the large input and sequence that is most relevant in the prediction problem. So now let us see the next deep learning model, that is long short-term memory network, that is LSTM networks. So LSTM networks, usually called LSTMs, are a special kind of recurrent neural networks, RNNs, that is capable of long-term dependencies. So they were introduced by Hockrater and Chemung Buer in 1997, and they were refined and popularized by different researchers. LSTM add explicit handling of the order between observations when learning a mapping function from the input to the output, not offered by multi-layer perceptrons and CNNs. They are the type of neural networks that add native support for input comprised of sequence of observations. So native support for the sequences is the advantage of this recurrent neural network, and these capabilities of LSTM can be used to a great effect in the complex problems such as neural networks, where the models learn the complex interrelationship problems. So learned temporal dependence. So the most relevant context of input observation to the expected output is learned and can change dynamically. Now, deep learning methods, that is long short-term memory LSTM, the method both learn a mapping from inputs to the outputs and learn what context from the input sequence is.
हाँ, जाना किधर है?
Is useful for the map.
हाँ, सीट तो है ना। बाहर क्या कर रहा हूँ? मैं पढ़ रहा हूँ यार। मेरे स्वयं का वो है ना। वैसे 1 बजे तो क्लास ही है मेरी अब। तो इधर ही आ जा, मतलब हो जाएगी। अरे दिखा है। बैठेगा। 300 तो बैठेगी और क्या कहेंगे? हाँ ये बैठेगी। नहीं मतलब हाँ, तुझे बताया कि मैं भी उस से वही तो बता मैं दवाई मना कर देती है। ये बाहर खिलाती है तो जाता ना बाहर नहीं जाना है। हमें आधा घंटा तो होता है, आधा घंटा तो बचा है। 12:30 को चलेंगे होंगे ना भाई। कहाँ से लेंगे भाई? कैंटीन। अब इतने ज्यादा बच्चे पता नहीं चले तो छोड़, ये छोड़ क्लास नहीं, क्लास में जाएगा। वैसे भी जगह होनी नहीं है मेरे को पता है। हाँ तो नहीं जाएंगे तो 3 सेक्शन होंगे। कुछ बाद में उन्होंने बोल दिया कि बाकी बच्चे आ रहे हैं। हाँ हाँ, यही बोलेंगे ना तभी तो हम लेंगे। यही किसी सीटी सेक्शन के बच्चे आ सकते हैं। आज तो जीवन देखो बोलेगा सीएमबी की आ जाओ, बाकी जीवन देखो और ये बाहर में दोनों मुश्किल ऑर्डर पे भाई। सीट पे क्या है? लैपटॉप पे चल जाओ, लैपटॉप पे चल नहीं है। ठीक है, 8 बजे तो बैठा है क्या? नहीं, 12 बजे से हाँ, जब करके फिर मेरा पिक
हाँ बोल। हाँ अंदर आ लास्ट में होना था। अर्जित अरे लास्ट में है बचा रखे थे पहले बैठना बैठ के बाद में और कितने लंबी है भाई तो है ना तूने क्या ले रखे हैं वो इलेक्ट्रिक पता नहीं मैं पर नहीं बोली सरप्राइज सरप्राइज हाँ ये फाउंडेशन ऑफ क्लाउड आईओटी सब कुछ मिला दिया सब कुछ ये क्लाउड आईओटी एमएल तेरा होगी स्वयं का ये क्या करेगा सबके साथ फिर क्या रखेगा स्वयं की प्लान फिर हम लोग पीपीटी और मैंने सिर्फ मैंने ना 1000 रुपये देने सोच रहा पीपीटी 78 मार्क्स कैसे है कैसे कोई कोई बच्चों को तो फेल करेगा पीपीटी देख बच्चों ने वीडियो नहीं भेजी वीडियो तो नेसेसरी थी तो मैंने सोचा कि क्यों रिस्क लेता हूँ आता तो इसमें सारा असाइनमेंट से ही है मेरे से इसमें करने को हमारा से आज शुरू करा मैंने पूरा काम कल आके रेट लूंगा ना 6 हफ्तों का कोर्स है 2 महीने का कोर्स एक दिन यार मन ही नहीं करता इसको पढ़ने में तो बने 1 घंटे के लेक्चर ही तो इसमें देखते भी खत्म कर दे बेटा अब किसी नोट आ गया समझ थोड़ी आ रही पढ़ क्यों रहे समझ नहीं आ रहा वो थोड़ा वैसे ऐसा लगना चाहिए ना दिखा दिखा लग रहा है अच्छा कि मारने में इजी रहे हाँ कितने मार्क्स का आता है इसका 100 नंबर नहीं यार कुछ मार्क्स इसमें उसके भी 70 का आता है पेपर और 30 मार्क्स असाइनमेंट भी हो रहे हैं कुछ जितना पता लग रहा है कि असाइनमेंट के मार्क्स आ रहे हैं कितने क्वेश्चन आते हैं मुझे नहीं पता ना तभी तो मैं पूछती हूँ जितना असाइनमेंट के मार्क्स होते हैं कितना नंबर का होता है सारे क्वेश्चन आ रहे थे इसमें मेरा कोर्स था बॉडी लैंग्वेज फेल कैसे नहीं हुआ बच गया ना बच गया मैंने रट लिया था उसको नहीं कोली उन्होंने एक्सेप्ट कैसे कर लिया कोर्स तेरा अच्छा ऐसे पता नहीं यार मुझे भी समझ नहीं आया तो मतलब कोई टेक्निकल कोर्स करता है ह्यूमैनिटीज का था वो कोर्स कोई क्या यार अरे वाह सपोज बोल इसके बाद किसी आज में क्या 6 बजे तक है? 3 बजे तक।
ऑटोमेटिक ही है आज। वो भी उधर हमारी ऑडी 5 पर उधर काम चल रहा है तुम्हारे लेवल 1 से 3
मिल जाना
तो क्लास लेंगे ऑटोमेटिक
नहीं तो और कौन पढ़ता है वहाँ पे तेरे हुए उसकी सर उसके देख मुझे बाहर
हाँ
दिखता तो
उसका एंड हो गया उसका देखना होता है कभी कभी सब पढ़ लिया उसने मशीन लर्निंग डीप लर्निंग बच क्या होगा बल्कि लैब में तो बहुत अच्छे नंबर आ रहे हैं उसका प्रैक्टिकल में ये समय बैक ये समय तो पास चल रहा है बहुत सारे बच्चे ऐसी पास कर दिया हमने तो कैसे बच गए इस बार के
फोटो देख लो आज में एकदम से वहाँ पे आ गया अच्छा स्पैम कर रही मैंने कर मैंने कर रहा था स्पैम करने का मैंने कहा
बेकार हो गया बालिक में
मेरा अगली पिक्चर
कमेंट करना था
इस्लामी
बच्चे खाना
देन लेके हम
क्या बताए कुछ सीख लें ₹1000 ले रहे हो
पागल है
बाकी तो 2500 लेगा
पैसे दिखाओ
मैंने सुना था हाँ कितने से बताओ 1 से 3 तक क्या है
चार सलीम चुकी हूँ
कौन आ रहा है
ये नहीं पता मे बी ये लोग सप्लाई निकाल लें
कौन आ सकता है
करण और जो टीचर की जानते हैं उनसे और थोड़ा लैपटॉप आर्टिस्ट कौन ही चलता है आजकल? कमी ले रहे हैं। नहीं दे रहा सारा कुछ।
पता है, बादशाह वाले में उनके मैनेजमेंट को ईमेल डाला था, तो उसमें आ रहा था ऐसे में 36 पता नहीं ऐसे कुछ लाख ले रहा। उसके बाद होटल वगैरह पूरे क्रू का जो
स्टे वगैरह।
वगैरह और जैगवार से उसका बैंकर बैंकर नहीं आएगी।
क्या सेफ्टी के साथ होती है? क्योंकि भैया सब एक सबसे बेस्ट होटल भी यहाँ पे मैं आती है।
है कहाँ पे?
टीआई के पास। ठीक है। तो भाई आते हैं हाथ में रुकवाएंगे यार से यहाँ आना। पता पिछली बार जो बच्चे मैनेजमेंट टीम में थे बच्चे मैंने सोच उसको पास को मैंने याद लेने गए। फिर यहाँ पर लेके आए पूरी टेस्ट में जो टेस्ट खत्म हुआ तब उसको मैं छोड़ देंगे। इतना जाम रहता है कि पूरे जाम क्लियर होता है उसके बाद निकलती है बात से। उसके बाद उसको हयात छोड़नी नहीं पड़ेगी है।
क्या मैं भी जाने वाला था पहले स्कॉटिंग स्कॉटिंग टीम में, पर उन्होंने मुझे बोला कि तो उसमें मैं पीछे था ना बैक स्पेस में उसका।
बैकस्टेज
अच्छा नहीं।
बैकस्टेज क्या कर रहा था 500 से निकला बैकस्टेज। क्यों कर गया करना तुम्हारा बैकस्टेज में मतलब क्या काम था तेरे को? ये तो तुम तो फिर उसको भी देखा होगा राखी में। कह रहा
तो ना राखी की रील देखी कैसे दिखा राखी का वो पेज।
मेरे भी पता हुआ पेज सर्च किया।
नहीं अरे यार वो कोई उसका है जहाँ मेकअप करते हैं उसकी क्या बोलते हैं कुछ और बोलते हैं
ब्यूटी
कोई ब्यूटी पार्लर का पेज है।
छोड़ दिए हमने।
अचानक से रील आ जाती है राखी के साथ उसकी।
ये तो बंद कर रहा है इंस्टा पे देखते शराब है।
चाइनी के ऊपर
मेरे क्या इंस्टा पे करने का आंटी का अकाउंट नीचे उनका आंटी का अकाउंट अकाउंट आंटी
मिलेगा भी।
मिल जाएगा।
अकाउंट
तेरे हाथ में मेरे फोन में क्रीम जी आते तो कहानी क्यों? गुलाब जामुन एक्चुअली कन्वर्ट थोड़ी रहती है जामुन बिना चाशनी में चाशनी लिखी है। So this is spoon का obviously पूरा बहुत detail दबा I'll be okay. Crazy actually. I'm really stiff.
ये check करता हूँ नहीं मार
I'm really fast. I'm really really
ऐसे नहीं होता है।
काल होती है ऐसे कैसे कर दी
पीछा नहीं आज करो
ये तो है काम हाँ तो मेरे घर चली जाती
1 से 3 मैं हमारी नॉर्मली तो 5 घंटे की होती है लगातार क्लास पहले 3 घंटा था कि 3 नहीं 2 घंटे था कि 3 घंटे और घर के
8 घंटे कर
अरे ठीक है यार तुम्हारा एक घंटा होता है ना ऑटोमेटिक की क्लास
सारी एक ही होती है हमारे सत्य में तो 3 दिन है
अरे अरे क्लास पहले हमारी उसमें हो चुका अच्छा तो फिर हमारे साथ पढ़ते हैं 6 बच्चे और अब इसने बोला कि हमारे ऑफलाइन लूंगा 3 2 0 थे 6 सेक्शन जी हाँ, एक सेक्शन